Okay, ma'am. So, good morning to one and all present for this second day of international conference on advances in applied mathematics, applied sciences, technology, and mathematics. And I'm very proud and also pleased to intro our today's very esteemed session chairpersons, Dr. N. Sundaram, Associate Professor, Head, Department of Statistics, Government Arts and College, Autonomous Nandanam, Chennai. In his 21 years of teaching experience, Sir has produced three MPhil dissertations, and Sir has currently guiding 6 PhD students. And also, Sir has been a research assistant in statistics at a National Institute for Research in Tuberculosis Epidemiology Unit, Chennai. In his teaching further, Sir has published basic concepts of statistics and higher and second year business statistics and max content expert in Tamil Nadu government. And along with our sir, we have another esteemed session chairperson, Dr. N. Sujata, associate professor in senior grade, Department of Mathematics, SRM Institute of Science and Technology, Chennai. With her 20 plus years of experience, ma'am has presented 8 papers and has published 9 papers in Scopus and Web of Science and 1 patent publishes in Scopus. And she also presented so many papers and she guiding 2 PhD students now. It's my pleasure to welcome you for today's session, sir. Ma'am, yes. I'm going to call out the name of the participants. Please, participants, be ready with your PPT presentations. We'll go with your first participant, Ms. K. Preeti.
Yes, ma'am. Hello, ma'am.
Yes, ma'am. Yes, you can share your screen, ma'am.
Okay, ma'am. Good morning, everyone. Today I am presenting on analyzing survival time of breast cancer patient, parametric and non-parametric approach. I am Preeti in MSc Biostatistics from SCNB Vaishnava College. Let's start my presentation on introduction. Breast cancer is a malignant tumor in breast tissue. It is one of the most prevalent cancer in women. Major cause of cancer-related death worldwide. Risk factor, biological factor, family history, hormonal influence, lifestyle choice. Types of breast cancer: HR2 positive, TNBC. Importance of early detection. Early diagnosis significantly improves survival rate and treatment success. Common screening method include mammogram, self-breast examination, and clinical screening. Breast cancer stages: stage non-invasive ductal carcinoma in situ, stage 1 to 3 localized and regional spread. Stage 4 cancer spread to other organs. This is my literature review. I have referred to my project. Problem in existing approaches. Following the literature, the present study aims to analyze survival rate of diagnostic breast cancer patient using non-parametric, semi-parametric, and parametric. The study employed Kaplan-Meier estimation, a non-parametric method, to estimate survival probability and compare survival distribution using log-rank test. The Cox proportional hazard model, a semi-parametric method, was used to assess the impact of multiple variables on survival by estimating hazard ratio. Additionally, the viable parametric model was applied to estimate hazard function and survival probabilities with multivariate analysis. Identifying significant prognostic factors, this method provides a comparative evaluation of breast cancer survival outcomes. Proposed methodology. Data from SEED program 2006 to 2010, 4024 breast cancer patient analyzed. Focus on infiltrating ductal lamellar carcinoma. The study analyzed variables such as age at diagnosis, race, marital status, tumor size, tumor grade, differentiation status, lymph node involvement, tumor stage T1 to T4, node stage T1 to N1 to N3, estrogen receptor status, progesterone receptor status, and survival time to assess breast cancer survival outcomes. Kaplan-Meier estimator non-parametric method estimate survival probabilities and generate survival curve. The log rank test compare survival distribution between group. Cox proportional hazard model semi-parametric method analyze the effect of multiple variable on survival time by estimating hazard ratio. Bible parametric method model survival data by estimating hazard function and survival probability. Multivariate analysis identify significant prognostic factors. Result and discussion. In Kaplan-Meier survival curve by grade with sensor data, the Kaplan-Meier survival curve shows the cumulative survival probability of breast cancer patient over time satisfied by tumor grade 1, grade 2, and grade 3. The survival probability decreases the time progresses with a steep decline after around 40 to 50 months. The curve for different grades are closely aligned, suggesting minimal difference in survival among them. Sensor data point indicated by the plus sign represent the patient who were lost of the follow-up or remain aligned throughout the study period without experiencing the event. Cumulative hazard function by tumor grade in breast cancer patient. The cumulative hazard function shows the increasing risk of the event, such as mortality over a time of breast cancer patients satisfied by tumor grade 1, grade 2, grade 3. The hazard start near zero and raises gradually within a steeper increases for after 40 to 50 months. The curve for different grades are closely aligned, indicating minimal difference in cumulative risk among them. In Cox regression analysis of predictor of breast cancer survival, the Cox regression analysis identified progesterone receptor status as only significant predictor of breast cancer survival, 0.0606 in p-value. Patients with positive progesterone receptor status have a lower risk of the death, indicating better survival. Tumor grade, estrogen receptor status, and differentiation are not statistically significant predictor. In multivariate analysis, viable parametric model with prognostic factors, present the multivariate analysis result from viable parametric model evaluating prognostic factor for breast cancer survival. Progesterone status is statistically significant, indicating its influence survival by grade, and estrogen status are not statistically predictor. Bible regression diagnostic plot for survival analysis by tumor grade. The log cumulative hazard plotted against the log transformed survival time for different tumor grade. The distant separation of the line highlight the impact of tumor grade on survival outcomes. In grade 4, demonstrate the highest cumulative hazard, indicating the poorest prognosis. Conversely, grade 1 to 3 exhibit progressively lower cumulative hazard, suggesting the better survival prospective. The near linear and parallel pattern of the line confirm the suitability of viable regression model and support the proportional hazard assumption. Comparison of viable model and non-parametric survival estimation. Comparison of the viable survival model With a non-parametric Kaplan-Meier survival estimate, the alignment between the two curves demonstrates the viable model suitability for the dataset, indicating its ability to effectively describe survival trend. Minor deviations, if present, may reflect differences between the empirical data and model assumption. This validation highlights the reliability of the
Ma'am,
viable
your
model.
session is out, ma'am. Preeti, ma'am, your session is out.
Yes, yes, ma'am.
Yes, ma'am, your session is out. If you want to continue, continue, ma'am. 10 minutes. Yes, each participant has given 10 minutes, ma'am.
Ma'am, 5 minutes, ma'am.
Okay, okay, okay.
Okay, thank you, ma'am. This validation highlights the reliability of the viable model for the survival analysis of predictions. Conclusion on future work. The study investigates the survival outcome of breast cancer patients by identifying and analyzing critical prognostic factors, including tumor grade, estrogen receptor status, and progesterone receptor status by utilizing a combination of non-parametric Kaplan-Meier, semi-parametric Cox proportional result, and parametric viable regression method. The study offered a comparative evaluation of survival pattern and identify key predictor. The result indicate that tumor grade and hormone receptor status, particularly progesterone receptor status, significantly impact survival outcomes. The viable regression model provides especially effective in modeling survival time, capturing varying survival rate across different patient groups. In conclusion, the finding emphasizes the importance of early detection, accurate staging, and hormone receptor status assessment in predicting breast cancer prognosis and enhancing patient outcomes. This is my reference paper. Thank you.
Hello,
Thank you, ma'am.
hello. Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay, okay. In the result and the conclusion part,
Yes,
yeah,
yes, sir.
uh, Priti ma'am,
Yes, yes, sir.
yeah, can you explain? You used the parametric multivariate analysis in the result and analysis. Okay.
Yes, yes, sir.
Can you explain the multivariate analysis? Is it correct term used in the Weibull model?
Multivariate analysis. Yes, sir.
Yeah. Do you know multivariate analysis?
Yes, 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 sir.
Is this the content applicable to use Weibull model?
Yes, yes, sir. Yes, sir. I
No, no,
agreeable.
no, no. Multivariate is the separate part. No, multivariate
Yes,
analysis is separate part.
yes,
Is
sir.
it correct, relevant to use your what is that your survival analysis?
Sir, I am using 4 variables, sir, in multivariate analysis.
No, no. The term is not correct. Okay.
Okay, okay, okay,
Multiple
sir.
variable, not multivariate, multiple variable. That is called covariate uh, or independent variable. Okay.
Okay, 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 sir. Okay, sir.
Multivariate is the another topic, the new topic. No,
Yes,
you
yes,
are using only the covariate, not for the
yes,
multivariate.
yes, yes, sir. Yes, sir. Yes, sir.
Multiple variable. Don't use multivariate, multiple variable. That is called the
Okay.
independent variable. Okay.
Okay, 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 sir.
Hmm. So otherwise, okay, no problem. So
Ah,
excellent presentation. Congratulations. Okay.
thank you, sir.
Okay. Ah,
Good morning, Preeti ma'am.
Yes, yes, ma'am. Good morning, ma'am.
It's a nice presentation. I wanted to know whether the data collections where you have taken,
Data collection is in Kaggle, ma'am.
how many data collections you have taken? You know the sample
4,000,
size.
4,024, ma'am.
So it has been related to all the age people, or only any
Yes,
criteria
yes,
is there?
yes, yes, ma'am. All the age people in
Okay.
30 above, ma'am.
Okay, then I can have an extension based on some support.
Ma'am.
women and you can compare. The very nice presentation. Separate
Thank you.
age
Thank
people like women. Nowadays, young stage is also there, na? So you can continue your research in such a way. All the best, ma'am. Nice.
Okay, okay. Thank you, ma'am.
Yes, thank you, Preeti ma'am. Thank you, ma'am. Thank you, sir. So we'll call the
Thank you, ma'am.
Thank you, ma'am.
next participant, Suma Nagendrappa. Sir, your PPT is ready. Please share your PPT, sir.
Yes, ma'am. Hello, ma'am.
No, ma'am, your PPT. No, sir, your PPT is not visible.
Network issue.
Okay.
Wait, ma'am. Network is.
Okay, we'll go. Okay, shall we move on to the next participant?
Ma'am.
Shall we move on to the next participant? You can rectify your side in the meantime. Okay, we'll move on to the next participant.
Ma'am, give network.
Yes, please rectify your side and we'll give chance to you at last. Don't worry. Okay, Ms. Sasikala,
Yes, ma'am.
yes, please
Can I
share your
start, ma'am?
screen, ma'am. Yeah.
Okay, ma'am. Good morning, everyone. I am Sasikala, student from Department of Biostatistics at the SDNB Vaishnava College for Women. Today, I will be presenting on drug performance evaluation using statistical method. Let's start with my introduction. A drug is substances used for diagnosis, treatment, prevention, or relief symptoms of disease. It is essential for managing disease, improving quality of life, and advancing medical science. Types of drugs: prescription drugs, over-the-counter drugs, generic drugs, and biologicals. Importance of drug performance evaluation: ensuring effectiveness and safety, enhancing patient awareness, regulatory compliance, economic impact. Drug performance evaluation in India. Regulatory frameworks governed by Central Drug Standard Control Organization and Indian Council of Medical Research and the Drug Controller General of India. Pharmaceutical market growth. India is the major global supplier of generic drug, requiring continuous evaluation. Challenges in India: accessibility and affordability in rural areas, need for more robust post-marketing surveillance, ethical concerns in clinical trials. This is my review of literature, which provides an overview of existing studies related to drug performance evaluation. Literature survey on the research topic showed the research related to drug satisfaction analysis predominantly focus on test-based and observational data. There are other studies measuring the satisfaction showed that follow both text-based and statistical-based approach exist. Therefore, statistical approach for analyzing drug satisfaction are very limited. Hence, in this study, statistical approach was applied to analyze structure rating data, including ease of use, satisfaction, effectiveness, average price,
Hello,
drug type,
hello,
and form of the drug.
hello, Mrs. Sasikala.
Yes, sir.
Hello, Mrs. Sasikala. Please show your methodology adopted in this paper and also show your the result. Okay, result and conclusion.
Okay, sir. Okay, sir.
Yeah.
Statistical analysis method. In this research, a comprehensive statistical approach was used to evaluate drug performance, incorporating multiple analytic techniques to gain deeper insight into medication effectiveness, user experience, and satisfaction. Explanatory data analysis, descriptive statistics, summarize key variables such as ease of use rating, efficacy rating, satisfaction also rating, and price. Identify the most common drug type and forms. Univariate and bivariate analysis examine the distribution of individual variables, explore the relationship between the satisfaction versus efficacy, ease of use versus effectiveness. Inferential statistics conduct chi-state tests to assess association between the categorical variables and using ANOVA to difference between the satisfaction level across the drug types. And cluster analysis segment user to satisfy and non-satisfy group based ease of use and effectiveness, reviews and price. Identify key characteristics of each group to understand patient preferences. And logistic regression analysis developed a predict model to determine factor influencing user task satisfaction, achieved a 94.79% accuracy, showing the reliability of key predictors, ease of use, efficacy, reviews, and price. This is my result and conclusions. Chi-square test performed to examine the association between the satisfaction and the form of drug. And the hypothesis, there is null hypothesis, there is no association between the satisfaction and form of the drug. The alternative hypothesis, there is a significant association between the satisfaction and form of the drug. The results showed a significant relationship between the form of the drug and satisfaction. And ANOVA analysis of variance conduct to assess the effect of the form of drug and satisfaction. The result indicate there is a significant difference between the satisfaction across the different form of the drug. Cluster analysis was conducted to examine the satisfaction in relation to use, ease of use, effectiveness, reviews, and price. Using the elbow method, two clusters were identified. K-means clustering result in two groups. A first cluster has 251 size and second cluster has 363 size. The average satisfaction level for cluster were first cluster have 2.27 and second cluster have 3.86. Based on this satisfaction level, cluster 1 and cluster 2 was classified as non-satisfied and satisfied customers. Logistic regression analysis was performed to predict satisfaction status based on the independent variables, ease of use, effectiveness, reviews, and price, and the dependent variable is satisfied and non-satisfied customers. The model predicts satisfaction status with a high accuracy of 94.79% with a confusion matrix table showing the true positive rate is 351 and the true negative rate is 231. The model was particularly effective at identifying the satisfied customer than the non-satisfied customers. Conclusion of my study. The study offers a comprehensive insight into a data set of 614 observation, revealing critical patterns and relationship among key variables. Descriptive statistics, ease of use, effectiveness, and satisfaction indicate moderate to high rating. Tablet were most common drug form and prescription dominate the data set. Inferential statistics, satisfaction was significantly associated with drug form and the various satisfaction levels. Cluster analysis categorizes users into non-satisfied and satisfied groups, emphasizing variation in satisfaction level based on the ease of use, effectiveness, reviews, and price. Logistic regression analysis further validate that these factors significantly influence satisfaction with the model, achieving a high prediction accuracy of 94.79% effectively, identifying satisfied customers. Overall, the study highlights the critical role of effectiveness, ease of use, reviews, and price in the shaping your satisfaction. Provide valuable guidance for enhancing customer experience and improving product offerings. This is my reference papers. Thank you.
Hello, Sasikala, no? Hello, am I audible?
Yes, sir.
Sasikala?
Yes, sir. Audible.
Yeah. Yeah. In the result and the discussion, in the ANOVA, okay, in the ANOVA,
Yes, sir.
yeah, you present only the form. So the form includes what are the factors?
Tablets, syrups, cream based, sir. Like
I
that,
think
sir.
the form is the group of the group variable. I think.
Yes, sir. Group of variables, sir.
Yeah. It comes under the what are the factors?
Tablet, capsules, cream based, injection, and syrup, sir.
Why don't you interpret the separate variable?
Sir, in frequency analysis, I separate the variables, sir. Which form of the drug patients mostly used? Is tablet, sir.
Yeah, my expectation is that we have to present each variable. But the what is that? These variable will reflect the whether the variables are significant or not. Okay, you studied only the group of variables.
Yes, sir. In future, I will do, sir.
Okay, okay,
Okay, sir.
okay, ma'am. Congratulations.
Okay,
Okay, thank you.
okay, sir. Okay, sir.
Sikla ma'am, nice presentation.
Thank you, ma'am.
Yeah, so you have to, whatever the sir is telling that you extend, and always whenever we are go along with the sample size, if you're moving a little bit more, we'll be giving the best level. Okay. And
Okay, ma'am. Okay.
if it is possible, you try to convert as a programmatic approach because it's a nice one. User nowadays it is more effective. So that is more
Okay.
important regarding the price. That you can
Okay, ma'am.
have some model. You develop a model, it is well and good. Okay.
Yes, ma'am. I plan to do machine learning, ma'am, in
Yes, ma'am.
future.
Yeah,
Okay,
ma'am.
ma'am.
All the best.
Okay.
Okay.
Thank you. Thank you.
Okay.
Thank you, ma'am. Thank you, sir. Okay, we'll call
Thank you,
out
ma'am.
for the next participant.
Sure, ma'am.
Sumitra, ma'am, hope you are ready with your presentation.
Yes, ma'am.
Please share your screen, ma'am.
Okay, ma'am.
Good morning to one and all present here. I am Sumitra. I am pursuing in MSc Biostatistics from SDNP Vaishnava College. My topic name is Clustering and Forecasting Millet Production in Tamil Nadu, Ramanathapuram district. The study aims analysis yield patterns across Tamil Nadu districts. Yield data for three key millets, cholam, kambu, and ragi, were gathered from the Department of Economic Statistics the period of 1986 to 2023. The districts were then clustered using the K-means algorithm based on the three millets. To analysis highlights, Ramanathapuram districts, which falls under the cluster one, is a dry climate, recommending millet cultivation during the moderate and severe drought years. The simple exponential smoothing failed the capture of millet yield trend, where Arts linear method indicate the declining trend for the cholam but not increasing trend for kambu and ragi. Hence, Arts linear method is suggested the more suitable approach forecasting millet yield in Ramanathapuram district. Here I have reviewed from the papers for my work. From literature survey, it is identified that the choice of location forecasting millet yield or production is purposive. The present study aims to cluster the districts of Tamil Nadu and select the most appropriate district for their analysis. Objective to analysis and standardize the millet yield and production data for 38 districts of Tamil Nadu 1986 to 2023 to apply the K-means clustering algorithm group the 38 districts of Tamil Nadu districts based on the millet yield and production patterns to evaluate and comparing the forecasting method to determine the most suitable model for predicting millet in Ramanathapuram district. cluster analysis used to 38 districts. The Tamil Nadu into 4 clusters is based on the millet yield and production after standardizing the data, time series decomposition, separated data into trend, seasonality, and residual components. Simple exponential smoothing used for short-time forecasting without a strong trend. Hertz linear model existing exponential smoothing into including trend, level of updated trend, updated forecasting. Result and discussion. The cluster is grouped for the 4 clusters. The cluster 1 is Ramanathapuram district, Sivagangai from etc. Cluster 2, Madurai, Theni, Virudhunagar. Cluster 3, Tirupur, Karur from etc. Remaining 18 districts for cluster 4. The K-means clustering was applied with the 4 clustering, dividing the 38 districts into the groups. The clustering explained the 66% of the total variation of the data. This method is identify the pattern, yield, and production, showing the clear difference between the group. Conclusion and future work. K-means clustering grouped 38 districts into the 4 clusters, explaining the 66% of the data variation for better agriculture planning. Cholam forecasting, Hertz linear model gives the best yield predictions by the capture trend effectively. Kambu forecasting, both simple exponential smoothing and Hertz linear model fail due to the very high error. Ragi forecasting, Hertz linear model is more accurate than seasonal simple exponential smoothing for Ragi yield predictions. Future improvements, advanced model is like the ARIMA and ARDL should be used for the better millet forecasting. Future work, prediction of yield and production is based on ML algorithm. Cholam production show a slight declining trend, decreasing from 2024 to 2028. Kambu production also declined gradually from 2024 to 2028. Ragi shows a sharp drop, straightening at the negative. Thank you.
Hello. Hello, Sumitra.
Thank
Yeah. The nice presentation.
you, sir.
Yeah. My question is, the estimated in the value in the year 2000, I think 28, the
Yes,
Rogi
sir.
value, the estimated value of the Rogi in the year 2028,
Yes, sir.
you got a minus 49. Uh,
Yes,
are
sir.
you identified any reason for that negative value?
I don't know, sir. I can use the Hertz linear model, sir.
No, compared to the previous year, no. Starting from 2024, okay,
Yes,
you
sir.
got, I think, 215, then 149, the value may be reduced, no.
Yes, sir.
What is your interpretation for that value?
So, production
Are you identifying the problem for that negative value?
will do, sir.
Okay, thank you.
Thank you, sir.
Ma'am, any question?
Yeah, yes. Good morning, Sumitra.
Good morning, ma'am.
Yeah, you have started whatever the sir is telling, you incorporate because that minus point is more valuable because what is the interpretation is more important. As well as the comparative study you can extend for some more like throughout Tamil Nadu, and
Yes,
I
ma'am.
saw that you have given, you're trying to reach an ML algorithm, isn't it?
Yes,
So
ma'am.
when you're completing that, if you're projecting as an algorithm, it is the best way of your research. Okay? All the
Okay,
best.
ma'am.
All the
Thank you,
best.
ma'am.
Okay.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am.
So we'll go for the next participant, Abhishek Karku.
Yes, ma'am.
Yes, please share your screen.
Thank you, ma'am. Is my screen visible, ma'am?
Yeah, sir, your screen is visible, sir.
Thank you, ma'am. Good morning, everyone. I am Abhishek Thakur, and
Sir,
today,
please make your presentation to full screen, sir. It's still in PPT mode. Please do in presentation mode. Go with
ma'am.
your slideshow, sir. No, please do with the slideshow, sir.
Ma'am, can you guide me from where?
Slideshow. No, it's in the toolbar itself. Home, designs, transitions, animation, slideshow is there.
Okay, ma'am. Thank
Slideshow,
you.
slideshow.
The bottom of it. Okay.
Slideshow from beginning.
Slideshow from.
From beginning.
Thank you, ma'am.
Yes.
Good morning, everyone. I am Abhishek Thakur. I am here to present my work on the analysis of convective instability in a ferrofluid layer saturating a porous medium. Dependent viscosity. Here, presentation. So, to begin, let's understand what a ferrofluid is. A ferrofluid is a unique liquid that becomes strongly magnetized when exposed to an external magnetic field. It consists of nanoscale magnetic particles such. These are some key properties and importance of the ferrofluid.
Okay.
Next,
We
application of
understand,
ferrofluids.
Abhishek. Yeah, Abhishek sir, please
Yes, sir.
present. Yeah, we understand that due to time factor, you just
Okay, sir.
show the objective of methodology and then the result and conclusion. Okay.
Yes. So, from where should I start, sir?
Yeah, the objectives. So objectives of your paper. Okay. What is your objective?
The, actually, sir, in this field there is a lot of work has been done, and still
Yeah, we
I
understand
found
and appreciated, but you just show your objective of the paper. No.
objective. Actually, there are a lot of applications of this work.
Okay. What are the method adopted in this paper? Okay.
In proposed methodology, I have
Yeah.
used a Darcy-Brinkman model, and we have applied Bosniak approximation, linear stability theory, normal mode method, and Galerkin method, which is used to solve the eigenvalue problem uh, to obtain the stability or instability of the system. This is, sir, my basic hydrodynamic equations and model. These are the eigenvalues equations. I am here. These are results and discussion. Here we found that first is variation of NC, where NC is a magnetic Rayleigh number. Hello.
Abhishek, proceed.
Sir, am I audible?
Yeah, audible. Yeah, proceed today.
Okay, sir. These are my results, and from these results I have found that the magnetic susceptibility significantly influence the stability of the system. The higher magnetic susceptibility enhance the stability. Why? Actually, we can see this from first figure. As Xi increases, Xi is a magnetic susceptibility, then magnetic Rayleigh number is also increases. So we can say that a system is stabilized. Similarly, the behavior of magnetic number is can be seen with the delta, where delta is magnetic field dependent viscosity parameter. So as delta increases, NC also increases for various values of M3. These all are discussed in the discussed here. The magnetization parameter M1 actually destabilize the system, because from this we can see that as M1 decreases, RC is a thermal Rayleigh number. These are future works. Uh, the first of all this was a hypothetical concept when Rayleigh Benard convection was considered with free boundaries. I have considered here some realistic boundaries, and in future we can extend this work to nonlinear and transient convection to study secondary instabilities and effects of magnetic field variations, analyze the impact of non-uniform and rotating magnetic fields on convection, anisotropic and heterogeneous pulse medium. We can consider that here I have considered isotropic pulse medium. And next, this can be extended to optimization and machine learning as well.
Okay, Abhishek,
Yes, sir.
the nice,
These are some
yeah, nice
references.
explanation. And
Sorry,
then
sir. Actually,
okay, okay. Uh, so excellent topic, but you have to explain the more. We are expecting the more result from your side. Okay. Uh,
okay, sir.
okay. Thank you.
Thank you, sir.
Thank you.
So good
Ma'am,
morning,
any question?
Abhishek.
Yes.
Good morning, ma'am.
Yeah, actually, you have told the comparisons and fixed. Is the threshold value what you have fixed, no? For the both?
No, ma'am. Actually, threshold value is obtained by calculating the.
Yeah, because you are
We have done all the
telling that for
calculation
the.
in MATLAB software.
Okay, okay. So you have given the last.
And we didn't set.
Yeah, tell me.
Ma'am, let me share one more time.
Yeah, okay. Okay, no time. Anyway, you have given the last one like some extension of the thresholds. You're going to give the using machine learning technique, isn't it? The last future work.
Yes, sir. Yes, ma'am.
Optimization and machine learning. Have you started the work? Because this work is nice.
Actually, ma'am, I am thinking
This
because I have
utilizing machine learning to predict.
I am start. I have started for non-linear, right?
Yeah. Because
Yes,
nowadays
ma'am.
this work is more important. Yeah, you please go ahead along with this, okay?
Okay, ma'am.
Especially
Thank you, ma'am.
non-linear. The research
Okay,
is
ma'am.
going on there. Okay.
Thank you,
All
ma'am.
the best. Nice
Thank you,
presentation.
ma'am.
Yes.
Thank you, ma'am. Thank you, sir. Sir, next participant, Riaz Khan, has not turned up. Shall we move on to the next participant? Yes, Deepa.
Yes, ma'am. I'm ready.
Okay. Ma'am, please share your presentation, ma'am.
Yes. Good morning, all. I'm presenting on the topic understanding long-term relationship between energy production and carbon dioxide emission in India, a
Ma'am, your
statistical
presentation, ma'am.
approach.
Deepa, ma'am, your presentation. Your presentation. Your presentation is not visible.
Share your PPT.
So is it visible now?
Yeah, it's visible, ma'am. Please make it as a slideshow.
Yes. Is it visible, sir? Yeah. I'm presenting on the topic understanding long-term relationship between energy production and carbon dioxide emission in India, a statistical approach. So carbon dioxide emission is a predominant factor for adverse climate disturbances. This gas has a high radiative force because of which it absorbs more heat than other GHG gases. Thus, it is a major contributor to global warming, and therefore it is necessary to model carbon dioxide emission. And India is the third largest emitter of GHG gas. There are many factors that contribute to carbon dioxide emission in India, in which we have chosen energy production from renewable and non-renewable sources, along with financial development and population growth are considered in the study. The study aims at understanding the long-run relationship between these variables so that it can be modeled for future projection and actions accordingly. These are the literatures in which the bootstrap ARDL model has been tested for the carbon dioxide emission and other factors in various countries. So ARDL bound test, which is the existing methodology, has a F test for testing the joint co-integrating relationship on the lag level of both dependent and independent variable, and T test on the lag level of the dependent variable. If F test favors the alternative hypothesis of co-integration and T test favors the null hypothesis, then it can be concluded that there is no influence of the lag dependent variable in the long run. This is generally termed as degenerate case 2. The degenerate case 1 is when the F test favors the null hypothesis and T test favors the alternate hypothesis. This can be ruled out by assuming the order of the dependent variable to be I1, which can be tested using unit root analysis. The BARDL test, that is bootstrap ARDL bound test, proposes an extra F test uh, uh, to test the null hypothesis of co-integration between the lag dependent variable. In that case, if the F dash, T, and the F double dash, which is the bootstrap ARDL test, all reject the null hypothesis, then it can be concluded that co-integration among the variable exists. And if the F double dash, that is the bootstrap test, is accepted, other two tests reject the null hypothesis, then the existence of co-integration is confirmed by assuming the dependent variable to be I1. And in the case where the T test is accepted and the F dash and the F double dash test reject the null hypothesis, then the existence of co-integration confirmed, consider only the joint movement of the dependent and the independent variables. Therefore, the bootstrap ARDL test for the variables considered for the both conditional and unconditional models shown here, the values of the F dash and the F double dash in both conditional and unconditional models are notably higher than the upper critical value. They also exceed the bootstrap critical value at the level of 10%. This leads to the conclusion that long-term relationship exists among the variables, specifically when examining the combined relationship between lagged dependent and independent variables, as well as the relationship among lagged independent variables alone. Therefore, the overall F statistics value falling in the rejection region confirms the joint significance of the dependent and the independent variable. The extra F test proposed for testing the co-integration of the independent variable also confirms the co-integration relationship among the variables in the long run. There is long-run relationship between carbon dioxide emission, renewable energy production, non-renewable energy production, and financial development of the country. With this conclusion, it can be used to model further these factors and can study the impact of these factors on the carbon dioxide emission. These are my literature reviews. Thank you, sir. Thank you, ma'am.
Hello.
Hello.
Yes. Deepa?
Sir.
Yeah. You compared only the model. Am I right?
Yes, sir. Yes, sir. Before
Uh,
modeling, the test I'm comparing. So test to be done before modeling, whether to find out whether they are integrated or not. I mean, co-integrated or not.
any the data used in this paper?
Yes, yes, sir. The data from for carbon dioxide emission, renewable energy production, non-renewable energy production, financial development, and population growth were sourced from the World Bank database for the year 1971 to 2014.
What are the factors included in that model?
The factors were renewable energy production, non-renewable energy production, financial development. Where the factors included, these are the independent variables, and carbon dioxide emission is a dependent variable.
Okay. Is there any difference between F dash and F double dash?
Yes, sir. Actually, F dash is the test for the joint co-integrated relationship on the lagged level of both dependent and the independent. Whereas F double dash is constructed for lagged independent variables alone.
Why don't you use the general F?
So general F test, sir, but it's for notational differences, it is given as F dash and F double dash. One is for joint of both dependent and independent, and one is for independent alone. That is why the notation, it's just a notational difference.
Uh, have you identified which model is the best?
Uh, Means the bootstrap ARDL or the ARDL. Bootstrap ARDL is performing better, sir.
Uh, what is the methodology behind this, the best one?
Because it is using the bootstrap critical values, not the exact critical values. Bootstrap critical values is especially for the small sample size. Because this from 1971 to 2014 is a 44 years of data, which is a small sample size for a time series type of data models.
Threshold value?
Threshold value
For that model?
No, sir, no.
Okay.
It's just the I1 value. So upper bound value is the threshold value. Sir.
Okay. Thank you. Nice presentation.
Thank you, sir.
Ma'am, any questions?
Yes, no question anyway, because she has given all the answers. But the only thing is, sorry, very good morning, Deepa.
Yes. Good morning, ma'am. Good morning.
So you have till 2014 only have collected the data, it seems, isn't
Yes,
it?
yes, ma'am. It's available only up to that year in the World Bank database.
Oh, there is no other data till, because
No,
now we are in the 2025 now.
23.
So
Yeah,
there is
yes, ma'am. Yeah, for India especially, the data is available only up to that date.
So because with this only we cannot conclude, because a lot of changes.
Yeah, agree, ma'am. Yes. Happened after that only, especially COVID and all happened only after that. So there might be a change in emission. So I should look into that.
Yeah, please look into that. Okay.
Yeah, sure,
Otherwise,
ma'am.
a nice presentation. Okay,
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay.
Thank you, ma'am. Thank you, sir.
Thank you. Thank you, ma'am.
Thank you.
Thank you. We'll go for the next presentation. Anil Raj, sir.
Yes, ma'am, present.
Okay. Kindly share your presentations.
First of all, good morning, respected sir and all participants. My name is Anil Raj. I am a research scholar of Patliputra University, Patna, and my topic is the optimization problem of production planning in application of linear programming, a case study on manufacturing water bottle. This is my outline, and this is my introduction. Linear programming models can be solved using
Sir,
a...
one minute.
Yes,
Your
yes.
presentation is not at all visible, sir.
My PPT is so.
Share your PPT. I think.
It's not at all visible.
Okay. I'm just. Yes, I think so. This one my PPT.
Yeah. Okay. Yeah. Now it's visible.
Okay. My topic is the optimize one. optimization problem of production planning. Yes. This is my outline and introduction. A linear programming models can be solved using a verify of technique, including the simplex method and interior point method and all the labs method. Linear programming models can be used to solve both uh, maximization, minimization problem. Linear programming models can have multiple optimal solution or no optimal solution at all. Linear programming models can be to solve complex real world problem. Linear problem models can be used to solve problems with multiple objectives. The main objective of this paper to find application of linear programming problem on production planning industry. The paper took three type of plastic water bottle with estimated profit, and the problem were formulated from the collected data. Hindustan Plastic Company manufacture plastic water bottle, and raw material for the research were collected from the plastic water bottle industry campaigning value. The formulated production planning problem was parametered into parametric linear programming and the production using the developed algorithm of linear programming. The production had resource product volume amount of resource used to produce each unit of product, and profit per unit for each product have been collected from the company. The data conjugate was used to estimate the parameter of linear programming model. The Hindustan Plastic Company has manufactured three type of plastic water bottle: 1 liter, 500 ml, 250 ml. 250 ml bottle produce 20 units. 500 ml bottle produce 3 units, and 1 liter water bottle produce 40 units. The content of water bottle per unit summarized. The amount of raw material used in plastic water bottle: polythene, high density polythene, low density polythene, polycarbonate, and political acid. The content of each raw material per unit water bottle produce summarize. Problem formulation: let the quantity of one water bottle produce A1, and let the quantity of a 500 ml water bottle produce A2. Let the quantity 250 ml water bottle produce A3. The profit of the maximization Z. Maximization Z is equal to 30 A1 plus 40 A2 plus 20 A3, and 0.4 A1 0.20 A2 plus 0.14 A3 less than 200. 0.20 A1 plus 0.14 A2 plus 0.16 A3 less than and equal to 160. 0.2 A1 plus 0.02 A2 plus 0.2 A3 less than and equal to 20. Of proposed methodology, maximum Z equal to 14A1 plus 13A2 plus 20A3 plus B1
Excuse me,
plus
sir.
B2 plus B3
Excuse me,
plus
sir. Anil, sir.
yes.
So just
Yes,
don't need to read it. Just methodology, conclude in a crisp manner. Okay? No need to read each and every step. Yes.
Oh.
Yeah.
This methodology I have used in this maximization profit in this production industry. Result and discussion. This paper considered an appeal production unit in Hindustan Plastic Company as a case study. The production held resource, product volume, and amount of resource used to produce each unit of product, and profit per unit for each product have been collected from the company. The data conjugate was used to estimate the parameter of linear programming model. The result obtained signalize the profit is made a different volume of parameter. Uh, Conclusion and future work. In this study, we were able to identify the problem faced Hindustan Plastic Company as a linear programming problem, formulated a mathematical model that represents the substance of the problems and the identity of the functions, a constraint of the problem, as well as solve a linear programming problem. From the solution acquired, we were also able to determine an optimal production programming problem for Hindustan Plastic Company. The data conjugate we used to estimate the parameters of linear programming model, the result obtained signalize the profit. I have given this reference where I have collected the data. Thank you.
Ma'am, please ask the question, ma'am.
Very good morning, Elraj. Sanil Raj, sir. Yeah. So anyway, it's a nice presentation. But these are all the model already. It will be existing now, like for optimization of any of the company.
Yes, ma'am. Already used in a long time.
So what is the innovative idea from you I'm expecting? Because it is already existing model. So is there any new innovation? Anything you are implementing?
Ma'am, at this time, no idea in implement of production industry.
Yeah, because it is already existing. Nowadays, a lot of invention is there, na? Everything, it's a model. Yeah. So try to think in an advanced level. Nice initiative. I am expecting more for the next one. Okay. All the very best.
Hello. What is that, Anil Raj?
Yes.
Yeah. Everything noted. The madam already noted. I expect what is the main objective of this paper?
Objective. Yeah. An objective formulated that calculated the quantity of cost maximization.
Are you maximizing the profit related or minimizing the cost?
Maximization profit.
Maximizing the profit.
Yes, sir.
Okay. So used, I think, the simplex method, no?
Yes, simplex method.
What is your output? You consider the program, no? Just you shown the maximizing the and the objective function, then the subject to the condition. So what is your output?
Sir, my output, yes. Yeah. Sir,
in the construction, okay, in the construction we used A1, A2, I think. Am I right? A1, A2, A3.
Yes.
But please change the notation, no? A1, A2, normally we use a constant, no? You have to use the variable, either X or Y.
Yes, sir.
What is your the output of the unit value?
We have calculated
A1, A2, A3 value.
A1, A2 is a decision variable.
Yeah, okay, correct. But what is the output of that program?
Output of program.
Yeah. What is your unit value?
Yes, I calculated this production is a maximization profit in this manufacturing industry.
Okay, based on the unit value, you have to show the maximizing the value, no?
Yes, sir, maximization.
So where is the output? Okay, please try to do. Okay, so thank you very much.
Thank you, sir. Thank you, ma'am. We'll go for the next participant.
Please, next the presenter. Yeah, next presenter.
Next person, Gunjam Baladevi,
next
has not turned up. So we'll move to the next participant, Vaishnavi.
Yes, ma'am.
Yes, okay. Please share your screen, Vaishnavi ma'am.
Okay, ma'am. Ma'am, is my presentation visible?
Yes, ma'am. Yes.
Good morning, everyone. Myself, K. Vaishnavi, research scholar. I'm carrying out my research under the guidance of Dr. R. Malini Devi ma'am, who is working as an associate professor in PG and Research Department of Mathematics, the Standard Fireworks Rajaratnam College for Women, Sivakasi. The title of the paper that I'm going to present today is Mathematical Modeling and Computational Analysis of Cashew Mosaic Virus Disease. So this is the outline of the presentation. First, we will see shortly about the causes, symptoms, and prevention of cashew mosaic virus. And the existing models, we will see about the other mathematical models that has been developed for cashew nut plant population. And then we will discuss about the mathematical model that we have constructed for cashew mosaic virus. Technologies that we have used to arrive at the approximate analytical solution of the model. And in the results and discussion section, the graphs represents the accuracy between the approximate analytical expression and the numerical solution. And we will discuss about the behavior of various parameters in different population. And then finally, conclusion and references. The causes for cashew mosaic virus disease is sap-sucking insects, and the symptoms include the mosaic pattern in leaf, change in the color of leaf and the shape of leaf. We can prevent this by controlling the insect vectors and cultivating resistant varieties. These are the already existing mathematical models that has been developed for various cashew nut plant diseases like fusarium wilt, artificial drying of cashew apple, bushfires in cashew dew nut plant, and optimal control model. This has been previously developed. Here we have developed a mathematical model for cashew mosaic virus disease. This model comprises of 4 compartments. This model can also be called as a co-infection mathematical modeling. In this co-infection mathematical modeling is nothing but a single host is affected by multiple vectors. Here the single host is the cashew nut plant and the multiple vectors are the sap-sucking insects. I equal to 1 to 3. The three here, the multiple vectors we have considered are airfish, cyclothropes, and emposca. These are the sap-sucking insects that are responsible for causing this cashew mosaic virus disease. And these are the list of parameters that are involved in our model. We use a negative sign in a mathematical model when there is an inverse relationship and a positive sign when there is a positive direct relationship between the population and the parameter. And here the methodologies that we have used are the homotopy perturbation method. In this method, what we do is we construct a homotopy as 1 minus p into the linear term of the system and plus p into the whole equation. Then we assume the solution to be in the form of a power series, and then we equate the coefficients of like powers of p, and then we arrive at the approximate analytical solution. By following the procedure, this is the approximate analytical solution of our model using homotopy perturbation method. And similarly, we have also used a new homotopy perturbation method. The difference between homotopy and new homotopy is in the difference in constructing the homotopy. There we construct it as 1 minus p into a linear term, but here we construct it as 1 minus p into the whole equation. But we consider the non-linear terms and the other remaining linear terms as an initial value, that is as a constant. Other procedures are same. So by following the algorithm in new homotopy perturbation method, this is the approximate analytical solution of our model. And now in the result and discussion section, all these graphs represents the accuracy between the approximate analytical expression and the numerical solution. In all the graphs, the dotted line represents new homotopy, star marker represents homotopy, and the solid line represents the numerical solution, which is arrived with the help of MATLAB ODE45 function. And here this first figure represents the rate of susceptible cashew plant population. Here we can see that the parameter that is varied is recovered plants that lose immunity gamma. As the parameter is varied, we can see that susceptible cashew nut plants slowly increases. For the higher value, we can see that the susceptible cashew plants started increasing. This is because when the recovered plants lose immunity, they become susceptible again. That's why it happens. And then here we can see that the infected cashew plants decreases with respect to time. Here the parameters that are varied are disease-induced mortality rate delta and infected plant recovery rate sigma. It is obvious that when the mortality rate of plant increases, automatically the infected cashew nut plant population decreases. And also as the recovery rate increases, the infected cashew nut population obviously decreases. That is why it, and then these figures represents the recovered cashew nut plant population with respect to the parameters sigma and gamma. Here also we can see that as the recovered as the infant population of the recovered plants to decline over time. This is why it happens. The recovered cashew plants decreases over time. And then finally, the vectors carrying the virus. This is the sap-sucking insect vectors that infect the cashew nut plant population. And here the parameters that are varied are rate at which the susceptible vectors become infected and natural mortality rate of the vectors. As the natural mortality rate of the vectors increases, gradually the vectors population also decreases. So in this way, we have analyzed the behavior of parameters in different population. And also we have achieved the accuracy between the approximate analytical expression and the numerical solution. Further, we can extend this work by implementing some real data. Also, we can analyze the model for stability and bifurcation. And these are some of the references that we have used in our paper. Thank you.
Good morning. Hello, am I audible?
Yes, sir. Good morning. Yes, sir. You are audible.
Sir, you are audible, sir.
Excellent topic.
Yes, thank you, sir.
Thank you very much.
Yes, sir.
But we need the more the interpretation. Okay.
Okay, sir.
Okay. Thank you.
Thank you, sir.
Ma'am, please. Ma'am.
So, Vaishnavi, ma'am.
Yeah.
Yes, ma'am.
It's sir told us like this. A very nice presentation.
Thank you, ma'am.
But you have taken only based on the time measurements you have given. The based on the mortality rate. That what is that the diseases recovery date it has been increased, isn't it? It's what
Yes,
you have
ma'am.
given, isn't it? So you have taken. Yeah, I need how many data you have taken, ma? Only few, or is there any sample sizes we needed, ma? How many things you have needed?
No, ma'am. We have assumed the value of the parameter.
That's what I am asking. It is an assumption only, isn't it?
Yes, ma'am. Yes, ma'am.
Is it so? It is even it is an assumption. It is coinciding, isn't it?
Yes, ma'am.
But even this is not perfect for all the criteria because you are assuming only few things you have taken. So let us go along with them some extra level. You just check it whether it is tallying or not, whether it is your assumption. Then only we can conclude the final things. Okay.
Okay, ma'am.
Okay.
I'll
Otherwise,
take
it's
it.
very nice. Okay.
Thank you. Thank you, ma'am.
All the best. Okay.
Thank you.
Thank you, ma'am. And thank you, sir. We'll move to the next participant, Anish Kumar.
Good morning, ma'am. Am I audible?
Yeah. You are audible. Kindly share your screen now.
My screen is visible or not?
Yeah, your screen is visible, sir.
Good morning, myself Avnish Kumar. I am research scholar of Central University of Himachal Pradesh. I am pursuing my PhD under the supervision of Dr. Pankaj Kumar, who is assistant professor in Central University of Himachal Pradesh. And my topic is effect of exponential and inversely various of viscosity with temperature on thermal instability
Sir,
industry
make
ferrofluid
your,
layer.
sir, excuse me, sir. Anish, sir, please make your presentation in a slideshow form so then we can view our presentation in full screen. Please make it as a slideshow.
The slideshow available in the bottom of the icon. Okay, the slideshow icon available in the bottom.
Is it okay now?
Now, no, slideshow. Please make a slideshow now.
Yeah. You go. It's okay. Just go for from beginning. Slideshow from beginning. Otherwise,
Ma'am, this is already in slideshow mode.
no, sir. Just go with slideshow from beginning, or else you can go with your toolbar in bottom. Just go for slideshow. Please click slideshow.
Yes, ma'am.
Yeah, there you will be visibling your from beginning, right? Just click on from beginning.
Yes, ma'am. And my topic is effect of exponential and inversely variation of viscosity with temperature or thermal instability industry ferrofluid layer with permeable boundaries. These are the outline of my presentation: introduction, existing approach, problem in existing approach, proposed methodology, result and discussion, conclusion, and future work and references. Fluid are substances that can flow and take shape of their container. They have easy deformation external influence and lack of fixed shape. The properties of fluids are viscosity, density, compressibility, ability to flow. And some examples are gases, liquid, and plasma. Ferrofluid is an example of a fluid which was invented by Steve Peppel in 1963 for liquid rocket fuel. A magnetic fluid that respond to external magnetic field, and it is a colloidal suspension of tiny magnetic particles. Particles are coated with a surfactant to prevent aggregation, suspended in an electrically non-conductive medium. The ferrofluid may not be pure all the time, but it contains some impurities. The special
Avinash
type of
Kumar,
ferrofluid containing small dust particles.
Avinash,
Yes, sir.
please show your what is that your slide? No, the slide is stable in the first slide only you shown. Okay, you are showing only the first slide. Please move to next slide.
Sir, I am moving on next slides.
It is not visible. No. Am I right?
Yes, sir. Yes, sir.
yes, sir. Yes, sir. Sir, I think Anish
Ah,
sir, you have presented your Windows on Windows only. You have not presented your full screen, I think so. Yeah, now it is visible.
I mean,
Now your
you
screen
didn't
is
click
changing.
the, yeah, you didn't click the slideshow mode, no?
Yeah.
Avinash, please click slideshow mode.
Is Anish
And
sir,
entire
please follow.
screen.
Yeah, please follow my instruction, please. Please share your screen.
Yes, ma'am.
Yes, go with slideshow.
Slide. Oh,
Okay. From beginning is there, no?
from beginning.
Yeah, just click it.
Yes, ma'am. Clicked.
I think your slideshow is not working. I think so.
Yes, ma'am.
I mean, the PPT in the bottom, it is available, ma'am. One the
Yeah,
icon
yeah.
is available, ma'am.
In bottom of the toolbar, that symbol is available. Slideshow symbol is available.
I think in the right hand side, the right hand side,
Notes, and after that,
bottom, yeah, bottom
yeah,
right hand side.
yeah, that only. Yeah.
No, ma'am. The
I
screen
think
is
your
not
version is
loading.
not updated. I think so. So only your slideshow is not available for this. Sir, is it enough, sir? This PPT is enough, ma'am. Is it this PPT is enough to visible?
Um, the icon is available in the what
Yeah,
is that
yeah.
in the
That icon is
percentage? Zoom.
available. See, F5 press also, ma'am. F5.
Is it enough in this mode?
Or
Sir,
you click one by one? No. Or you click one by one?
okay, sir. Okay.
Yes, sir.
Yes.
Okay. Then move to next slide.
Anish, sir asked you to
Dusty
present.
fluid.
Present. Yes, sir asked you to present.
Okay.
The thermal convection is firstly observed by Count Rutherford. The heat transfer in fluid caused by temperature difference. When heated from below, fluid expanded and rise up and temperature gradient overcome gravity and form cellular motion pattern in the fluid. Approach and related work. Suspended particle in ferrofluid play a crucial role in performance and applications. Key research contribution. These are some literature review and problem in existing approach. Influence of dust particle on thermal convection. Temperature dependent viscosity effect. Impact of permeable boundaries. Problem in existing approach. Mathematical model. For this, we consider a horizontal, infinite horizontal extended layer with vertical thickness d, and dust particle are embedded within ferrofluid. Lower and upper boundaries are permeable and maintained at uniform temperature T0 and T1. The ferrofluid is electrically non-conductive, and temperature dependent viscosity of the fluid is given by mu1 f of t, and the gravity act only along z-axis. Proposed methodology. Fundamental equation. Establish the core equation governing the system based on physical laws. Basic state. Identify the system's initial motionless state. Perturbations, linear analysis, normal mode analysis, non-dimensionalize, Pellow-Southwell technique, solution method. Apply the Glaricon method to solve the eigenvalue problem and resultant discussion. These are the governing equations. Equation of continuity, momentum equation, energy equation, and density temperature relation. For dust phase, the equation of continuity and equation of motion are given by this, and the temperature dependent viscosity mu, which is is equal to mu1 f of t, where f of t is equal to exponential minus gamma t minus t naught and 1 upon 1 minus gamma t minus t naught for inverse linear variation. The solution for basic state when no motion present in the fluid is given by these equations. And after that, the perturbations are applied in uh, equations of motion continuity and equation of energy, and then the basic state solution are applied in obtained equation. After that, using normal mode analysis, uh, we find equations in only z axis. The equations are non-dimensionalized. After that, we get eigenvalue problem in this form. These eigenvalue problem for stationary solution are obtained by putting omega is equal to 0, and also the m2 is very less than. So this is also omitted in next calculation. These are the permeable boundary conditions, and applying a Galerkin technique, we obtain the expression for Rayleigh number and magnetic Rayleigh number as this, where I1, I2 up to I7 are given by these integrals. Using the MATLAB software and uh, the polynomial solution that satisfies the initial boundary condition, we solve these eigenvalue problem and obtain the solution. For numerical validity of the numerical program, the obtained result are compared with the existing result for m1 equal to m3 equal to 0, and in the absence of dust particle h1 ka dash is equal to 0, and these results are in very good agreement with existing result with Dhiman and Kumar. These are the graphs obtained for the equations. And conclusion, PES is valid for this problem no matter the border permeability convective being in a stationary mode confirmed by Pellow Southwell technique. The boundary permeability parameter delay convection onset stabilizing the system regardless. The temperature dependent viscosity parameter delay convection onset for exponential variation and accelerate it for inverse variation. In both the cases, the convection cell size at onset change based on the boundaries permeability parameter. The dust particle parameter speed up convection onset for all hydrodynamic boundary condition and viscosity model, but does not affect the convection cell size. The non-linearity of magnetization parameter accelerate convection onset for the hydrodynamic boundary condition and viscosity model. As it increases the convection cell size at onset also grow for both viscosity temperature dependent relation. Thank. And this is the future work. This problem can further be investigated for with many other effects like rotation, permeable medium, and Coriolis force, etc. And these are the latest references used in our research. Thank you.
Good morning. The nice presentation, the excellent topic. Uh, Avinish Kumar.
Ji sir. Yes sir.
Yeah. In the resultant discussion part, okay. You have used some model, okay.
Yes sir.
Okay. The present study and the Dimon and the Kumar study, okay. The alpha value, the previous study, what is that alpha C? Yeah? You used the notation alpha C or AC?
Yes sir, AC.
AC, okay. I think in the serial number 1, it shows that 2.669, in the present study 2.6698, okay.
Yes sir.
And in the serial number 2, the alpha C value 2.699, then the present study given 2.700.
Yes sir.
So from these results, so what is your conclusion? Have you identified any the significant and relevant information?
Sir, actually, the result obtained by Diwan and Kumar are obtained only for a particular case
Yeah, I think more or less
for
same.
lower
No,
free and
I
upper
think more or
rigid
less.
boundary.
Oh, I think more or less
But
same.
we get a general case which is applicable for all type of boundary condition like free, rigid, free, and free, rigid. So I think these results for general case are very close agreement for particular cases also.
No, no, more or less same. No, both the previous and the present study given the more same result. No.
Yes, sir, but these obtained our result are a particular case for existing study when we put M1, M3 equal to 0 and H dash is equal to 1. That is when in this case no dust particle present in ferrofluid and the magnetic character is also 0. But we can extend our result for M1, M3 by taking different magnetic parameters and the value of H dash that is dust particle parameter
I think
are
no
also
difference. No, there is no
varies.
difference. No. Avinash Kumar, there is no
Yes,
difference.
sir.
No. Ah.
Sir, this is the comparison for particular cases, but there are also difference because we changes the H dash. In the case of Diman and Kumar, the H dash is only one, but in our research, H dash is also variable. In case of Diman and Kumar, M1 and M3 is only 0, but we also
Yeah.
changes M3 for different cases.
Okay, okay. You discuss with your guide. No, you discuss with your guide.
Yes,
Just
sir.
you improve the better result. No. Okay. Thank you. Congratulations
Yes.
to you.
Thank you, sir.
Madam, please.
Yes, sir. Yes, sir. Good morning, Anvesh Kumar.
Good morning, ma'am.
Yeah, what you have told, actually, I'm seeing the particular case, and even it is the you have changed only the regarding M3 value alone, and even H dash you have put it as a variable, it seems, isn't it?
Yes, ma'am.
H dash is only a particular value or a different variables?
Yes, ma'am.
All kind of values it will be satisfied for your present study.
Yes, ma'am.
So you are concluding at all at any type of H test, we are we are having the same resultant from the
Yes,
previous
ma'am.
result. That is what you are concluding.
Yes, ma'am.
Okay. So what we are expecting is even the initial of zeros value also, we are getting this what the sir is telling the same value. Even the change of the numbers also, we are having the same value. There is no deviations at all. That is what we are having a doubt. Okay. Because there will be some changes should be occurring now. That will be leading to the better results, better conclusion. That is what we are expecting. Uh, Even we are changing the variables also, there will be some sort of changes should be there. This is what accordingly we are thinking. Just you go along with that. Okay. Otherwise, it is a nice presentation. Congratulations. Okay, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am. Thank you, sir. Sir, shall we move to the next participant? Anisha, sorry, Ashika, ma'am. Ashika, ma'am, you ready for your presentation?
Yes, ma'am. Am I audible?
Yeah, you're audible. Yeah, dear participants, yes, please be patient. If you have joined late, you'll be given chance. Okay, ma'am, you can share your screen now.
Is it visible, ma'am? Is it visible, ma'am?
Yeah, ma'am, it's visible. Please make it as a slideshow.
Yeah, ma'am. Is it okay, ma'am?
Yeah, okay, ma'am.
Good morning, everyone. Myself, Ashika T.S., research scholar under the guidance of Dr. S. Asha, Nesabani Memorial Christian College, Martandam. My topic is some variants of radio contra harmonic mean graphs and its application on sequencing problem. This is the outline of my presentation. Introduction. Labeling is an important part of the large field graph theory. Labeling graph is a crucial approach that assigns a label to a vertex edge or both based on predetermined criteria. Radio labeling is a kind of graph labeling which gives each vertex a different, a distinct label with the requirement that the label of neighboring vertices differ sufficiently depending on the graph's distance from one another. Assignment problems are a form of sequencing problem that asks how to allocate n goods to n machines in the most efficient manner. The objective is to process all of the jobs as quickly or cheaply as possible. Radio contra harmonic mean labeling is a novel radio labeling parameter that we introduced in this paper. The constraint that arises for the corresponding graph is used to calculate some of its variations. The sequencing issue are then solved using those attributes. Existing approaches. The rationale of the channel assignment problem introduces the radio labeling method to the broad and fascinating field of graph theory proposed by G. Chatton et al. The notion of a graph radial radio number was first presented by Avidapan et al. In 2017. Radio and radial radio number of certain sunflower external graphs were estimated by Mohan K. Kabar and Kim Yoke. The idea of radio contra harmonic mean number of graph was introduced by T.S. Ashika and S. Asha. R. Kalpakako et al. Encountered several graphs radio coloring concepts. S.M. Johnson and R. Bellman first presented the sequence challenging problem, finding the optimal sequence for the processing a finite number of jobs and a finite number of machines is the focus of the topic. So this is the methodology I used. Here we defined a radio contra harmonic mean number of a graphs. For a connected graph G, the mapping f from V of G to zero union natural number is called a radio contra harmonic mean labeling if it is satisfies the inequality geodesic distance between u comma v plus CL of f of u square plus f of v square divided by f of u plus f of v greater than or equal to 1 plus greater than or equal to 1 plus radius of the graph G for every distinct pair of vertices. The graph which satisfies radio contra harmonic mean labeling is called radio contra harmonic mean graph. Radio contra harmonic mean number of f is symbolized by RRCHMN of f is the maximum number assigned under the mapping f. Further, the radio contra harmonic mean number of G is denoted as RRCHMN of G, which is equal to the minimum span taken over all possible RRCHMN of f, such that f is a radio contra harmonic mean labeling of G. So these are the attributes we again defined for a radio contra harmonic mean labeling L. The number of distinct labels used is the radio contra harmonic mean score, which is denoted as RR cap of S, RR cap S of G comma L. Uh, and RR cap M of G is the radio contra harmonic mean mark is the number of distinct labels utilized in a radio contra harmonic mean labeling with the lowest score. Similarly, the sum of the labels utilized is the radio contra harmonic mean weight, RR cap W of G comma L of a radio contra harmonic mean labeling L. The radio contra harmonic mean cast RR cap C of G is the sum of all labels used in the radio contra harmonic mean labeling. The smallest distinct labels utilized is the radio contra harmonic mean weight, RR cap W of G comma L of a radio smallest distinct labels utilized. Radio contra harmonic mean bandwidth RR cap B of G is the difference between the largest and smallest used distinct labels in the radio contra harmonic mean labeling with the shortest gap. So this is an example for the above parameters. Here in graph 1, we obtained a radio contra harmonic mark, but others are different. In G2, we obtained radial Kanda harmonic cast, and in G3, we obtained our radial Kanda harmonic bandwidth of G. Here, the graph is same, but the pattern of labelings are different for a single graph. Results and discussions. For any connected graph G, RR cap N of G is equal to R of G. Every connected graph G admits RR cap M of G is equal to 1 only under a particular labeling. If RR cap M of G is equal to 1, then RR cap N of G is equal to R of G. The converse of above theorem is not true. Then result, if RR cap M of G is equal to 1, then RR cap C of G does not exist. Theorem, if RR cap M of G is equal to 1, then RR cap B of G does not exist. Next theorem, for any connected graph G, if RR cap B of G is equal to 1, then RR cap S of G, L is equal to 2. The converse of the above theorem is also need not be true. And application in sequencing problem. Here we introduced a new algorithm known as Ash's algorithm. Here we used some graphs like star graphs to represent the two machines. Step 1, using Johnson's algorithm, first we define the optimal sequence. Now we obtain an optimal chain. Using this chain, construct a new optimal table and set ui the value of ith position job in the optimal table corresponding to the machine A, and set vi the value of ith position job in the optimal table corresponding to machine B. Step 2, construction of graph. Here we construct two graphs for G1 and G2. G1 represent the graph where the job for machines A are allocated, and G2 represent the graphs where the jobs for machine B are allocated. And we defined a mapping L from V of G1 restricted view to processing timing for machine A, and L from V of G2 restricted V to the processing timings for machine B. And setting L of U is equal to 0 and L of V is the smallest processing time. Here we get two isomorphic graphs G1 and G2, which must be radial Kanda harmonic mean graphs. Now in step 3, we set I is equal to 2 such that summation j is equal to 1 to I uj plus uv less than or equal to summation j is equal to 1 to I minus 1 v of j plus v. Then set I tends to I plus 1. Repeat the step 3 until I tends to n. Afterwards, the resultant updated graph of G2 is represented by G2 dash and stop. Go to step 5. If not, proceed to the next step. So step 4, if summation j is equal to 1 to I uj plus u greater than summation j is equal to 1 to I minus 1 vj plus v, then add L of ki to RHS such that summation j is equal to 1 to I uj plus u is equal to summation j is equal to 1 to I minus 1 vj plus v plus ki. Now set summation j is equal to 1 to I uj plus u, which is equal to summation j is equal to 1 to I minus 1 vj plus v, and set I tends to I plus 1 and repeat the step 3. Step 5, to calculate total elapsed time and ideal times for machines. Hence, total elapsed time is equal to RR cap C of G2 dash. Ideal time for machine A is equal to RR cap G2 dash minus RR cap C of G1. Ideal time for machine B is equal to RR cap C of G2 dash minus RR cap C of G2 plus L of V. This is an example for the above algorithm. Here we are going to allocate 6 jobs for machines A and B. While applying that algorithm, we get a graph G1, a star graph, and whose RR cap C of G1 is equal to 30, and also we get the graph G2 RR cap C of G2 is equal to 30, and after applying step 3 and 4, we get a new graph G2 dash such that RR cap of G2 dash is equal to 33. So now using those attributes, we calculate the total elapsed time, ideal time for machine A and ideal time for machine B. Conclusion and future work. Radio Kanda harmonic mean labeling is a relatively new graph labeling approach that we used in this paper, and some of its modifications are also discussed. These techniques are paired with a novel algorithm we developed for a sequencing problem of assigning n work to two machines. Future research can explore the possibility of assigning n job to n machines through the use of such techniques. These are my references. Thank you. Ma'am?
Yes.
Any question? Yes.
Ashika, good morning, Ashika.
Yes, ma'am. Good morning, ma'am.
Yeah. So I hope you and your guide has introduced this concept, radio control labeling, isn't it?
Yes, ma'am.
Or is there any existing already?
No, ma'am. No, ma'am. This is defined by me. Radio control labeling is defined by me.
Radio control labeling is defined by you
Me, yes,
only.
ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
So what is the difference? Because you have given only the connected graph.
Yes,
Is there
ma'am.
any difference between your
Yes, ma'am. Yes,
old
ma'am.
one or
Actually,
your? Yeah, please.
yes, ma'am. Actually, in old problems we have. Just a minute, ma'am. Okay. Here we are giving a connected graph because of here. If we look at equation, there is a geodesic distance between u comma v.
Yep.
So, this is exist only if the graph is connected, because if we have two components, if we choose one vertex from component 1 and one vertex from component 2, we can't take a distance between those two vertices. So there will not exist any distance between those two vertices. So for that purpose only we are taking a connected graph. So we can done this methods only if the graph is connected, because we can check these conditions between every two distinct vertices. So we have take the connected graphs only. And similarly, the difference between there's already a radio radial mean graphs. Here I find radio contra harmonic mean graph. The difference is the number which I got is less than those one. In distance we have, in distance the we have to minimal the number. So this is the more prominent one than radio mean labeling. So I defined radio contra harmonic mean labeling, which is more prominent and effective than radio mean labeling.
Okay. And one more thing, you have chosen the connected graph. All cycles, is it
Yes, ma'am.
all cycles or tree, any graph, is it okay? All the connected graph, like complete graph, tree.
Yes, ma'am, it will exist but the number will vary.
Have you checked all the graphs?
Yes, ma'am. Yes, ma'am.
Like all the complete
Because
graph, new.
yes, ma'am. If in complete graph, easily we can label every, if we take a complete graph Kn, which means we can easily label it with every vertices n. So if we check those conditions, it will satisfy, because the radius
No.
of the
My
complete
question
graph
is,
is one.
have you tried that complete graph, bipartite graph, everything? Have you tried regarding your new innovation?
Yes, ma'am. Yes, ma'am.
Okay. Okay, ma'am.
Yes, ma'am.
So,
Okay, ma'am. Thank you.
but you have to correlate both things, because so many new graph, because you have shown only this, it is not a complete graph, but you have tried for an application sequencing problem. You try
Yes,
along with
ma'am.
the complete as well as bipartite and a lot of different versions. No? There
Different
you
question.
correlate.
Yeah.
Yeah, it's a new
Yes,
tech,
ma'am.
really nice.
Ma'am,
You try along
ma'am,
with.
actually in this result and discussion, I write here I generalize those things. Actually, for G, we can choose any connected graph. So complete graph, bipartite graph, star graph, a tree, anything, whatever we want, we can choose the graph. Just we have to choose the graph which is connected. It is enough, ma'am. So only I have
It
written the
is
theory.
tallied in the theorem.
Yes, ma'am. Yes, ma'am. Yes, ma'am. It is tallied, ma'am. So I generalized all those graphs using this particular theorems. You can choose whatever you want. You can check. It will satisfy, ma'am.
Okay, nice. Okay.
Okay.
Yes,
Thank
sir.
you, ma'am. Okay. Thank you so much.
Hello, madam.
Yes, sir. Good morning, sir.
Good morning, good morning. In the introduction part, okay,
Ah,
am I audible?
yes, sir. Yes, sir. Yes, sir. You're audible, sir.
In the introduction part, you mentioned no assignment problem or form of sequencing problem that ask how to allocate the n job and the n mission. Okay. What is the concept you used in this
Sir.
paper? Okay, so but your illustration part, in the illustration part,
Sir.
you just done. I'm
Ah,
audible.
Yes, sir. Yes, sir. You're audible, sir. Yes, sir. Now you are
Yeah.
audible, sir.
But in the introduction part, you mentioned the N boots and to N mission, no?
Yes, sir.
Okay. But in the
Yes, sir.
illustration part, you used two
Uh,
mission, six jobs. Okay.
yes, sir. Yes, sir.
Is there any relevant?
Yes, sir. Yes, sir. Actually, in the introduction part, I generally mentioned assignment problems are a form of sequencing problem. We can allocate n good to n mission. But in this paper, this is just an introduction for assignment problems, sir. In this paper, I have done for only two missions. But actually, we can done it for n missions, sir. Like, um, just a minute, sir. If we
Is,
take
is,
two, if
no, no.
sir.
Is this applicable for N jobs, N mission?
Yes, sir. It will applicable. There exist n isomorphic graphs, sir. So we get n times g2 dash. I think g2 dash, g3 dash, up to gn dash. So because of n missions.
Okay, already we have here the procedure. So how to solve the sequencing problem. Okay.
Yes, sir. Yes, sir.
What is
Yes, sir.
your new methodology adopted in this paper?
Here, sir. Actually, there is a method that we use in table like such things. Here I have used to calculate the parameters which I introduced in graph theory, and same time
What parameter? What parameter? What parameter?
radial contra
Yeah,
harmonic mean
yeah.
parameters, sir. So only
We
here I
we have
calculated the
here
total
the type of the mean. No, why didn't you use the another mean? You use only harmonic mean. Is it applicable for other means?
uh, I think it will. I don't know, sir. But for we can't use radio contra harmonic mean is not applicable, but radio contra harmonic is applicable because of the function defined, sir. In radio
No, no.
contra harmonic,
Why you use the harmonic mean? Is it applicable for other mean? Is
yeah,
there
maybe,
any
sir.
intention? Yeah, is there any
No, sir.
intention to
Actually,
do this?
no, sir. Just I'm working in contra harmonic mean area, so only I choose to those methods, sir. Otherwise, no, not at all. No idea about others, sir.
Okay. And the illustration part,
Uh,
in the first GL1 and GL2, no, GL1, GL2. In the GL1, the pattern, I think you used all are in the three, no. But in the second pattern, no, GL1, 2, what is that? GL2, GL2. You
yes,
used
sir.
the zero. So you used the zero. So zero
Yes, sir.
indicates what is the meaning of a zero?
Actually, it's a defined the labeling which is defined in that manner, sir. Wait a minute, sir. So this is what I defined. So we can allocate the vertices from zero union n.
No.
Uh,
I'm expecting the clear picture. Okay, the pattern is same. The value you used the value, no, 2304. Am I right?
yes, sir. Yes, sir. Yes, sir. Yes, sir.
Already used zero and three. No, the pattern is same.
Yes, sir.
Is
Yes,
it
sir.
correct? Is it
Yes,
correct?
sir. Yes, sir. Yes, sir. Yes, sir.
No, is it correct or not?
Correct, sir. Sir.
I think it may be changed. The pattern may be changed. No.
Yes, sir. Actually, we can change the pattern, sir. Here, I choose this kind because to show you in graph G1.
No. Changing the pattern or structure. Okay. All are showing the
Okay,
same.
sir.
The pattern or structure. No.
Yes, sir. Yes,
The
sir.
values are different.
Different.
No.
Yes,
Uh,
sir. Yes, sir. So,
so
actually, I.
please conclude. Please discuss with your guide. No.
Okay, sir. Okay, sir. Okay, sir.
Okay.
If we consider G comma L1, we get radio contra. we get, but that is not a minimal. So we label in different pattern. In this pattern we get mark, a minimal mark. In this pattern, as in G comma L2, we get a cast. If we compare G comma L1 and G comma L2 in graph G comma L1, the weight of the graph is 33, but in G comma L2 the weight of the graph is 18, sir. So uh, our aim is to our aim is to find the minimal one. So comparing these two type of labeling, in type of labeling one, we obtain the mark. In type of labeling two, we obtain the cost, sir. So in that manner only we can variate these things.
Okay. Your intention is to reduce the, I think, the ideal time of the mission, the both mission.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, ma. Thank you. Excellent presentation. Thank you very much. Thanks.
Thank you so much, sir. Thank you so much, sir. Thank you.
Yes, thank you, Ashika. Next participant, Delhi. Can you present?
Thank you, ma'am.
Yes, Delhi. Can you present? Miss Delhi, will you there?
Hello?
Yes. Yes,
Hello?
Miss Delhi, will you there?
Ma'am,
Yes. Yes, you can start. You
I
can
have
start.
I have network problem. Can I present after that?
Network issue.
Hello, ma'am.
Can you correct it? Can you correct it? It will take some more time.
Yes,
Okay, okay. Then you can wait. Yes, next participant, Ravindra Nahi. Will you ready?
Yes, ma'am.
Yes, then you can proceed.
Okay.
Your voice is audible, so you can start. Yes, Ravinder.
Yes, ma'am. Ma'am, is my screen is visible?
No, we didn't see your PPT.
Now?
Your voice is audible, but we didn't see your PPT presentation. I think you left. Ravinder, will you there? Ravinder? Is Ravinder?
Hello,
Ravinder,
hello.
yes, yes. You're audible. You can start.
Yes, ma'am.
You can show your PPT.
Yes, ma'am.
Ravinder, your time getting late now. We are waiting. Please start.
Sure, ma'am.
You can start your presentation. Ravinder, shall we go next participant? Okay, we will go next participant. His next participant, Aham Begum Sujit Ajit Singh. Will you there?
Yes, madam.
Yes, yes, you can
Is it
start, sir.
audible? Is
I
it
think,
audible to use, ma'am?
sir?
Is it audible?
Yes, you're audible. Little more louder.
Good afternoon, respected chairpersons, Dr. N. Sundaram and Dr. N. Sujatha, and my dear colleague research scholar. I am Wahangan
1 minute, sir. So you can present your PPT.
Yes, I will share it.
Okay. Okay, start.
Sir. Dạ. Chúng tìm hiểu. Please wait 1 second, ma'am. Slide share over. Okay. Can you see it, ma'am?
Yes, yes. You can start.
Today, my topic of presentation is common fixed point for two mapping in cone ASP metric space without assumption of normality of cone. This is some outlines of my presentation and introduction part. Just wait 1 second.
Sir, please go to objective part.
Introduction parts. The celebrated Banach contraction principle is the most commonly and widely used theorem in all branches of analysis because of its simplicity and usefulness as a powerful tool in solving nonlinear problems. Various generalizations of this theorem.
Excuse me, sir.
Ma'am.
Excuse me. Yeah, good morning, Sujit. Can you please go to the objective part directly?
Ma'am, you mean my main reason?
It is your methodology, what you're going to project. Directly, please.
It is the proposed methodology of my research paper. We have studied many.
What, sir? Directly?
Ma'am, we have studied many regions in cone S metric space and cone SP metric space in the existing literature. From these reasons, we are trying to give theoretical proof of some regions which are completeness and normality of cone relax. And these are the reasons we have established from the existing literature. In theorem 1, let XS be a cone SP metric space with coefficient S is greater than or equal to 1, P be a solid cone, and FZ are self-mapping from X to X which satisfy the following conditions. For domain of X codomain of F is subset of codomain of Z, F of X or G of X is complete, S of F of X, comma Fy, comma Fz is less than or equal to AS of Zx, comma Zy, comma Zz plus Bs of Zx, comma Fx, comma Fx plus Zs of Zy plus Fy plus Ds of Zz, comma Fz for all x, y, z belongs to capital X, where A, B, C, D greater than or equal to 0 and A plus twice Bs plus twice Cs of S squared plus Ds is less than 1, then F and Z have a unique point of coincidence in X. Moreover, if F and Z are weakly compatible, then F and Z have a unique common fixed point. It is the theorem number 2. Let X S be a cone, S be metric space with coefficient S is greater than or equal to 1, P be a solid cone, and Fz are self-mapping from X to X, which satisfy the following conditions. Point number 1, F of X is subset of Z of X. Point number 2, F of X or G of X is complete. Point number 3, S of Fx, Fy, Fz is less than or equal to AS of Zx, Zy, Zz plus B S of Zx, Fx, Fx plus C S, Zy, Fy plus D S of Zz, comma Fz, comma Fz for all x, y, z belongs to capital X, where A, B, C, D greater than or equal to 0 and
Sir,
A plus.
sir, hello. Sir, have you applied any applications in this paper?
Sir, I am trying to apply these theorems in integrand transform.
Just you derived the theorem, or just you are reviewing the theorem?
Please, sir, I can't hear you, sir.
No, this is existing derived theorem or newly derived theorem?
Sir, they are newly derived theorem, and my paper is mainly established from Young or Yang and one paper, namely Young or Yang and Hong John Choi common fixed point 0.42 mapping in n cone metric space.
Okay, you didn't apply any the application part.
Sir, for that application, I am not establishing right now, and I am trying to.
So, okay, what is the use of this theorem?
Sir, in in the paper, I have in the paper of Young or Yang and John Choi, they are doing in n cone metric space, and I am doing this paper in SB metric space, which is more generalized and more.
Yeah, we understand that. What is the main use of this theorem? Okay, you derived some theorem. Okay, what is the use of the theorem?
Sir, so we are trying to we are trying to use it in integrand transformation or other
Okay. Please try to discuss with your guide, no? Okay, and do some application. Okay. Okay. Thank you.
So right now we are. I am not giving the application part here.
Yeah, we understand that we derived some properties. No, you derived some properties. We understand that. So we are expecting the usefulness and the application part. Okay. Okay. How you get it?
Sir, you want me to show the application right now?
No, if it is okay, if it is applicable, if you have some application, please show that. Otherwise, you just leave it. Okay, no problem.
Okay, sir.
No problem.
So is it,
Excellent derivation, sir. We understand that you derived some properties. We appreciate it, and we expect the application part.
Oh, so right now I have not that application.
Okay, no problem, sir. Please, yeah. Ma'am, have you any question?
Yes, Sujit sir, could you please go to the last conclusion slide?
Yes, ma'am. This is the conclusion part of my slide, so ma'am.
So higher space like cone, a metric space, only this you have tried. But better scope of applicability only, that is what the sir is telling, isn't it? Okay.
And
so
I work on...
Yeah, please.
Ma'am, I work on cone SB metric space, and my regions can be extended to cone A metric and cone AB metric space also.
Okay, so whatever it be, nowadays we are expecting the resultant should be correlated with an application. Okay?
Yes,
your work is nice, but we are expecting the related application towards your research is well and good. So try to correlate over there. Okay?
Okay, ma'am.
Otherwise, it is nice. Okay?
Okay.
Okay.
Thank you, ma'am.
Thank you.
Yes, thank you, Siddharth Singh. Next participant, Geeta Lakshmi. Can you ready? Yes, Ms. Geeta Lakshmi. Ma'am, Geeta Lakshmi, ma'am. Yes, Geeta Lakshmi, ma'am. Shall we go next participant? So next participant, Rahul. Rahul will be there. Rahul Makpana. Rahul, are you ready to present? Rahul? Okay, leave it. So next participant, Suma.
Yes, ma'am.
Yes, you can start.
Yes, ma'am.
Sir, actually, Suma is the second participant, sir.
Yeah, I understand.
Ma'am, Suma is the second participant, ma'am.
Okay, ma'am.
Okay, ma'am. Thank you.
Ma'am, screen is visible, ma'am.
Wait.
Screen visible, you have to share the PPT, no?
Yes, sir. Good morning, everyone. Myself is Scholar of Mathematics under the guidance of Dr. Raghunath Kyar from Davangere University. That my title is a thermohaline convection in a MHD Kessan fluid over an exponential stretching sheet.
Yes, ma'am, your screen is visible. You can start. Your voice is not audible.
Hello, ma'am.
Yes, start. Continue.
Ma'am, screen is not moving.
Screen visible, ma'am. You can continue.
Ma'am, screen is... Wait, ma'am. Visible, ma'am, screen?
Now it is not visible.
Wait, ma'am. Now, ma'am?
Yes. Now it's visible.
Okay, ma'am. These are the outline of our presentation. Next, first one is introduction. Thermohaline convection is a natural
Now,
convection.
please make use of on the slideshow. No.
Sir, data is structuring, sir.
Slideshow available in bottom on the right corner. No.
You can directly use F5. Suma, ma'am.
Ma'am, this is stuck, ma'am.
It will be stuck now.
Ma'am, can I present in phone, ma'am?
You can present through phone.
Okay,
What? Tell me again.
Can I present use phone, ma'am?
Yeah, ma'am, but
Phone.
yeah, ma'am, the
But,
time
ma'am,
is moving on. Your time is moving on. Our sir and ma'am is waiting. No. So please be ready. Dear
Sorry.
participants, please be ready with your PPTs. Ma'am, shall we have another candidate in the meanwhile? Sir?
No problem, ma'am.
Yes,
you
yes.
just.
Ma'am, please give me chance, ma'am.
Okay.
These are our outline of the presentation. First one is introduction. Thermohaline convection is a natural convection.
No. Move to the objective part.
Application, sir.
Objective. What is your objective of this article?
Yes, sir. We have to Sorry, sir.
Suma, you just show the objective methodology. What are the methodology adopted in this paper, and show your result and discussion. Oh.
Yes, sir. But laptop is stuck, sir. Network issues, sir.
No issue, ma. Please do one by one. Okay.
Sir, laptop is hanging. Sir, can you use the phone presentation?
Okay, ma. Please do it.
No, it's enough. Sir, can we move to the next participant in the meantime, sir?
Yes, sir.
Suma ma'am, you can use your mobile. So once
Yes,
you're
ma'am.
ready, please chat with your chat box, right?
Yes, ma'am.
Okay, thank you.
Sorry, ma'am.
Participants, please, time is so valuable. Please be ready with your PPT presentations. So we'll move on to the next participant, Konjam Baladevi. Konjam Baladevi.
Yes, ma'am.
Yes, please present your screen, ma'am, please.
Okay, ma'am. Am I audible, ma'am?
Yes, you're audible and your screen also visible. You can start.
Okay, ma'am.
You can start.
Good afternoon, everyone.
Continue, Baladevi.
I mean, your voice is not audible.
Baladevi, are you presenting? We are able to see the screen only. Baladevi ma'am, are you there? No. Sir, she's not there in the meet. Sir, we move to the next participant, sir.
Okay, okay.
Hello, ma'am.
Hello,
ma'am.
Ma'am, what happened to your presentation?
There is some network problem. Can I continue?
Please.
Then there is the introduction of my paper. And this is the related works I have gone through. This is also the related works I have studied. And this is the problems in existing process. In this existing process, there is an equivalence between cone metric spaces and metric space on the sense of the existence of fixed point of the mapping involved. In order to generalize and overcome these flaws Liu and to introduce the notion of a cone metric space over Banach algebra by replacing the Banach space E by Banach algebra A, which became a significant role in the study of fixed point theorem. Ma'am, am I audible, ma'am?
Yes,
you can proceed here.
Okay. And this is the
Alade ma'am, could you please go to the directly objective methodology conclusion because of the time constraint, okay?
Okay. This is the proposed methodology. The different fixed point region in various generalized metric spaces are studied. We also studied the concept of coupled fixed point of a mapping as introduced by the Bhaskar and the Lakshmikantam, and also the different coupled fixed point theorems in various spaces, especially in cone metric space, cone SB metric space, and cone AB metric space. On the other hand, we studied the new notion of cone AB space over Banach algebra, cone SB metric space over Banach algebra, and the different fixed point regions therein. We then attempted to use all these ideas to introduce cone AB metric space over real Banach algebra and extend the common fixed point region to this space. And this is the reason we have developed theorem 1. Let X, A be a complete cone AB metric space over real Banach algebra A, and let P be a solid cone in A. Suppose the mapping F from X cross X to X satisfy the following condition: A f of X, Y, f of X, Y, f of U, B less than equal to K A X X U plus L A Y Y B for all X Y U B belongs to X and KL belongs to P with rho of K plus 1 less than 1 by B square, where B is a constant. Then F has a unique common fixed point. Then this is the second region we have developed. Let X, A be a complete cone AB metric space over real Banach algebra A, and let P be a solid cone in A. Suppose the mapping F defined from X cross X to X satisfy the following condition. Here is the condition: for all X, Y, U, B belongs to X, and KL belongs to P with rho of K plus rho of L less than 1 by N minus 1, B cube, and K and L commute with each other. Here, K and rho of K is the Spartan radius of K, and rho of L is the Spartan radius of L. Then F has a unique coupled fixed point. Then we have the third reason here. X, A be a complete cone AB metric space over real Banach algebra A, and let P be a solid cone in A. Suppose the mapping F defined from X cross X to X satisfying the following conditions. Here is the condition. Then K and L belongs to P with maximum of rho of k, comma, rho of L less than 1 by 2 n minus 1 whole square b cube, then FSA unique Kaupan fixed point. Then we have the conclusion and future work. We can still explore the existence of fixed point, coincidence point, and common fixed point in the setting of cone AB metric space over real Banach algebra. We then can seek to find the areas of useful application of the region so far developed and the other potential region which can be developed. Then we have the references. Thank you, ma'am.
Miss Baladevi, ma'am, it's nice presentation.
Yes, ma'am.
But here also you have derived some of the theorems, but you have not projected the applications where it is used, isn't it?
Yes, ma'am.
Exactly. So try to incorporate, as well as you have given every theorem that n, there is a conditions you have increased, isn't it? The first one, second one, third one. So what is the meaning of n? Can you please give? That n, rho of k, comma rho of L, which is less than or equal to 1 by n something. Every time you're using n, what does it mean? N.
L. K and L. K and L are the
n.
K and L are the vectors.
Okay. So
some vectors, ma'am.
What, ma?
And rho of k and rho of L is the rho of k is the spectrum radius of k. K means vector, spectrum radius of the vector.
That I am not asking. No, I am not asking that. You have mentioned that n. What does it mean? Is there any restriction of n? Small n you are using, na?
Yes.
Yeah, what does that
n
mean?
is a natural number.
It might be any number. There is no restriction.
N belongs to n belongs to natural number.
That is what n belonging to what? What field? You have not mentioned some n. What does mean of n?
N belongs to set of natural number.
Only natural numbers.
Yes, ma'am.
Isn't it? But if it is...
Yes, ma'am. Hello, ma'am.
Natural numbers means your condition is not satisfied, na? And if it is equal to 1? Can you see n equal to 1? It is infinity, isn't it?
Yeah.
Yeah, please think upon that, okay? Because because there is no number. It is telling only the infinite values. Otherwise, it is okay. But you please think accordingly the numbers, whether n not equal to 1 or something. You please show it. Okay. Yeah.
Okay,
nice presentation. Okay.
Thank you, ma'am.
Hello. Hello. Am I audible?
Hello, sir.
Yeah.
Yes, sir. Yes, sir. Yes, sir.
Madam pointed out very excellent. Your maximum of and what is that the row of k and row of L? No, less than 1 by 2 in b power 3. Okay, am I right?
Yes, sir.
So in this part you have to mention the limit of n. Okay, the limit of n.
Okay, sir. Okay, sir.
If n is 1,
I will
if n is 1,
I will.
yeah, if n is 1, it may be what? Infinite, no.
Yes, sir.
Okay. And you are mapping to the real Banach algebra A. Am I right? AB metric space over real Banach algebra A. Okay, am I right?
Yes, sir.
What is the use of the real Banach algebra A? And another question, why you are mapping with the real Banach algebra? Okay.
In some recent research, some scholars develop there is an equivalence between cone metric space and metric space. So some author develop the Banach algebra to find the accurate fixed point.
Okay. We have a lot of the metric phase, no. So why you mapping with your Banach algebra, no? Is there any reason?
I think.
And also, we are expecting some three property you derive, no.
Yes,
we
sir.
are expecting the application part of that the properties, no.
Yes, sir. We try to develop the application part.
Okay, so otherwise, okay, excellent presentation. Congratulations to you. Okay, thank you.
Thank you, sir.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am.
Next participant, Derly.
Hello. Yes, ma'am. I am ready.
Please present your screen.
Yes.
Sir, still two more participants are there, sir. Without
Okay,
Derly.
no issue. No issue.
Ma'am, two more participants are there. Sujata, ma'am.
Yeah.
Hello.
No issues, ma'am. No issues.
Okay,
Hello,
ma'am.
ma'am.
Thank you.
Hello,
Yeah,
ma'am.
your
Hello,
you
ma'am.
are you're visible. Your screen is visible, ma'am. Please
My
present your
screen
screen.
is visible.
Yeah, audio is also clear. Please start your presentation.
Okay. Good
Yeah, we stick
afternoon
to 10
everyone.
minutes, please.
Yes, ma'am. Can I start? Hello.
Yes.
Good afternoon to everyone. I presented paper on application of double general ranking integral transform in system of linear and non-linear PD. My research guide is Dr. D.P. Patil, sir. So this is the outline of my presentation: introduction, existing approaches, proposed methodology, discussion, conclusion, and future works and references. So first, here I include the introduction. I review some research paper related to the system of partial differential equation with linear and non-linear PDF. I include that here. Now, next, this is also the introduction. Now, next is the existing approaches. I use some existing definitions and integral transform. First one is the ranking integral transform. This is the definition of ranking integral transform. Now, next is the generalization of ranking integral transform. Here we define the this integral transform on the domain from minus infinity to 0, and which is from the set H. I define this set here. Now, next is the double general ranking integral transform. I developed this integral transform definition of the double general ranking integral transform, which is also defined on the domain minus infinity to 0 on two variables. The set will be defined and be denoted by the notation h2g, such that the function h of t1, t2 here exists for n, capital N, lambda 1, lambda 2, psi 1, psi 2 greater than 0, mod h of t1, comma 0 greater than n e raised to lambda I t1. T1 belongs to the domain minus infinity to 0. Also, the mod comma T2 greater than M e raised to psi j T2. T2 belongs to minus 1 raised to j minus 1 plus minus infinity to 0, where ij is equal to 1, comma 2. Where is capital M are finite constant, lambda 1, lambda 2, psi 1, psi 2 are the finite or infinite constant. Now, using on that set, we find the double general integral transform. We did it by the notation of beta to g of t1, t2, and I transform denoted by the notation lambda between mu1 mu2 in this space mu1 mu2 equal to 1 by mu1 mu1 raised to n1 raised to n from minus infinity to times p mu1 t1 plus u mu2 t2 h of t1 t2 d1 dt2. Here I will use this notation for uh, s- denoting the transform. P mu1, P mu2 are the functions of parameter mu1 and mu2. Now, next, I will use the theorem in my previous research paper. This is the one theorem. Uh, I can use this theorem to apply for solving the system of PD. So here, this is the statement theorem. Hello. I will take the double general ranking integral transform for partial derivative. First order, second order, and this is the generalized nth order partial derivative. Now, next is the next theorem I will develop here. Hello? Hello, ma'am.
We are audible, ma. You continue.
Okay. Now, also, we develop the next theorem in that double general ranking integral transform for partial derivative with respect to the variable t2. In first theorem, we take the partial derivative with respect to the variable t1. Okay. Now, these are the some common functions, double general ranking integral transform that I use in application. This is the standard functions. Okay, one t1 t2. Next e raised to exponential function, trigonometric function, cos 81 bt2 sin 81 plus now, next I will apply the main aim of this paper, or in this paper I will work on to apply the double general ranking integral transform for solving the system of partial differential equation. Here, firstly, we consider the linear system of partial differential equation. Okay, this is the system ut1 plus vt2 is equal to 0, uvt1 plus ut2 is equal to 0 with this initial condition and boundary conditions. Now, I apply the double general ranking integral transform to the system of partial differential equation, that is for the these two equation, and we get using the theorem 1 and theorem 2 I get the transform of these equations. Now, also we take the single general ranking integral transform for the initial condition and boundary conditions. Next, I will putting this condition in the equations 1 and 2 and taking its taking some after calculations, we get the
Monali ma'am, your time is up.
Ma'am, you go to the what is that your result? Okay, the output of the result.
okay. So I apply the double general ranking integral transform for solving the system of linear PD, non-linear PD also. For
Okay,
non-linear
we
PD,
understand that. We understand that. Go to your result part.
result. Okay. I successfully applied the double general ranking integral transform for solving the system of linear and non-linear PD.
Okay, Delhi ma'am, you derived so many the methodology, no? Please go to result part, result and discussion part.
Hello.
Yes,
Hello.
audible. Yeah, go to the result and discussion part, ma'am.
Okay, okay, sir. System of PDs of integer order have been successfully solving using the double general Rangine integral transform. Additionally, the double general Rangine integral transform is used in conjunction with the iterative technique to solve the system of nonlinear PDs of an integer order. Uh, Using this technique, like the Adam and decomposition method, variational iteration method, differential transform method, the same solution has already been found for the examples. But here I apply the double general ranking integral transform to get the exact solution of linear and
Okay,
non-linear
have you
system of
applied any real data set? Have you applied in any real data set or real applications?
real. I will take these examples from other research papers.
Okay, you have adopted so many the methodology,
But
no?
I
We have adopted so many
but there
methodology, no? So among the methodology, so which one is the best, giving
yes,
best result?
uh, the double general ranking iterative transform with the new iterative technique uh, applying, so we get the better result other than existing.
Okay. In future, please try to apply some the real applications, no?
Real sir, I apply also this for couple burgers equation. Lastly, I
Okay, okay. Very nice presentation. Thank you. Ma'am, please ask some questions.
Yeah, Derry ma'am, it's a nice presentation.
okay.
Have done a
Thank
lot of
you,
work,
sir.
but whatever you are given the proposed methodology, you have to tabulate as well as in a graphical approach. If you are showing, it will be giving a clarity which is best. Also, as is there any you just convert as a real-time applications where which is best that you please extend. Okay, but
Yes,
you have done a
yes,
very
ma'am.
good
Okay.
job for extending a lot of methods. But that will be the focusing towards the which one is best by using the tabulation as well as the graphical approach.
Okay, ma'am. I will
Okay?
try. Okay, ma'am.
Okay.
Okay.
Nice presentation. Yeah.
Okay, ma'am. Thank you.
Thank you, ma'am. Thank you, sir. We'll move on to the next
Thank you, ma'am.
presentation. Rahul.
Yes,
Can I
madam.
stop, ma'am?
Yes,
My
please
screen.
share your screen, sir.
Am I audible,
Yes.
madam?
Yeah. You're audible, and be stick to 5 minutes only for your presentation.
Okay. Can you
Yes.
see my screen, madam?
Yes, you are audible and screen is visible. Please start your presentation.
Okay, namaste and a very good afternoon to one and all present here. And thank you very much for giving me the opportunity to present my paper entitled with solving a nonlinear time fractional Fisher and Gardner equation using adomine decomposition Shehu transformation method along with Caputo derivatives. Uh, Under the guidance of my name is Rahul M. Makwana and I'm from Marwadi University, Gujarat. So this is my outline of the presentation. In introduction, fractional calculus was first convinced centuries ago by Leibniz and Euler. And due to its versatile applicability, it is an essential area of study in modern science and technology. Especially Fisher and Gardner equations are central to modeling various physical and biological phenomena. R.A. Fisher has derived the Fisher equation in 1937, and Fisher equation has many applications and widely used in ecology, biology, epidemiology. Especially here this picture representing the real life example application of a Fisher equation, and that is a wildfire spreading through a dry forest, representing a Fisher equation in the context of biological invention. Almost similar graph or shape or pattern in upcoming slide you will see as a 2D or 3D graph of a Fisher equation example, which we derived by our methodology, that is Edomine decomposition Shehu transformation method. Similarly, the Gardner equation derived by Clifford Gardner in 1968 is an extension of KdV equation. Is to be used in various fields such as plasma physics, fluid dynamics, quantum mechanics, etc. Such nonlinear equations are solved by various approaches ranging from analytical to numerical methods. This is another real life application of Gardner equation, and that is the solitary wave formation on a calm surface of ocean, which representing a Gardner equation in fluid dynamics. Again, we will see the similar graph image in the Gardner equation 2D, 3D image, which we derived by new method. We inspired to fabricate a hybrid technique for obtaining a solution of partial differential equation with different constraints, which is called by Edomine decomposition Shehu transformation method, which is a combination of Edomine decomposition method and Shehu transform. Shehu transform was
Please go to the methodology and objective and the methodology. What is the methodology? Yeah.
Yes, sir. These are the
need to give the definition and the other things. No.
Sir, this is the methodology.
Equation mainly focus methodology adopted in this paper and show your result and discussion. Okay.
Definitely, sir. 6 and 7 are generalized form of fractional order non-linear differential equation. In 7, we are having initial conditions. If we apply Shehu and inverse Shehu transformation to equation number 6, we will get equation number 8, on which if we apply Edomine decomposition method, and if we write equation number 8 in a series solution form, we have equation number 9, where an is Edomine polynomials, which gives recurrence relation as Wxn form, where summation of W0, W1, W2, and so on gives the exact solution of nonlinear fractional partial differential equation. So this methodology we have derived, for which we have used the convergence theorem, and this is the first application named by Fisher equation. Equation number 13 representing Fisher equation. 14 is initial condition of given equation, and for value of beta is equals to 1, the exact solution is represented in equation number 15. As I said earlier,
hello, sir. Hello.
W0, W1, and so
what
on.
is the main contribution in this paper?
Sir, we derived the two solution Fisher and Gardner equation using Edomine decomposition Shehu transformation method.
Okay.
And sir, this is the graph, 2D graph and 3D graph of Fisher equation, which simply indicate that if beta is equals to 1, when it gets closer and closer to 1, we will get the exact solution, which I said earlier by showing the slide of real life application of wildfire.
Can you explain with a real situation?
Yes, sir. Sir, this is the graph. This is the graph of, you can see figure number 5, left side graph. This is obtained by Fisher and our method. Right side graph is the actual.
No. I am expecting the real situation and the situation adopted in this the graph.
Sir, we can compare this graph with the real situation, as I said here.
Yeah, please explain with this real situation.
Yes, yes, sir.
So
Yes.
your beta indicate the beta indicate. What is your the beta?
Yes, sir. Sir, wildfire spreading through a dry forest is shown in this slide, where if you can see from the left side, the beta is small. When it gets closer and closer to more values, suppose beta is 0.5, 0.6, 0.7, when it gets closer and closer to 1, here you can say it has an exact solution. Similarly, we have derived solution for Gardner equation. Should I continue, sir?
Yeah. If you are going to increase the beta value, what will happen?
It will simply give solution to the exact solution which we have in the equation.
Are you increasing the beta value or decreasing the beta value?
No, increasing, sir. Sir, here it is. Say for 0.7, 0.8, 0.8, 0.9, we do not have the graph which is showing right side to your screen.
Okay.
But
If your beta value goes to minus 1.1, what will happen?
So, sir, it simply will give this situation. Here you can see the left side part is the very small value of beta, sir. The right side part is the maximum value of the beta.
The highest peak point represent the beta value. How much the beta value? Approximately.
In this equation, for considering equation, we have taken 1, sir, for which we are having exact solution of the equations.
You are relating to fire, no?
Yes, sir.
Your fire may be reduced or high.
It is both, sir. It is reducing as well as it is going up, and accordingly, it has a similar graph which we have in the equation.
Okay. Only the beta value reflects the situation, no?
Yes, sir. Yes, sir.
Is there any intention behind this concept?
Sir, we are taking 3 variables exactly. If you can see in the graph, x values are there, t values are there. That is beta.
Okay.
Should I continue, sir?
Okay, sir. Okay, sir. Then move to the conclusion part.
Fine, sir. Fine. Sir, this is the second equation. It's graph and similarly tabular representation. In tabular representation, you can see we have taken x values, t values, then exact solutions by 2 different methods. Another method is NHPM, that is a natural homotopy permutation method. It is a very good method which gives a very good solution. So we compare our method with that method to uh, see the effectiveness of our method. Even the absolute error by both the method with exact solution is counted. And I have kept tabular formation. We have kept tabular formation for both the equation. So, sir, this is the conclusion part. That the result shows that the ADSHTM, our method, that is adenine decomposition Sehu transformation method, is an effective method to solve both fractional Fisher and Gardner equations. This method enables researcher to inquire precise approximation solution that allows reveal fractional order effects on dynamic system characteristics. In general, this research demonstrates the broad applicability of the method for solving fractional order differential equation in various scientific and engineering fields. And that fractional order we have taken as beta, which I used to say. These are our references. Thank you. Thank you very much, sir. Thank you all.
Thank you very much. Another nice presentation. Congratulations to you. Ma'am, please ask the question.
Thank
you. Yes, sir. Yeah, very good afternoon, Rahul. It's a very nice presentation as well as a new different way of thinking towards. But when I have seen the table values there in the 10, 5, you are giving some particular values. Have you, please go the table.
Yes, madam. Can you see it?
Because you have compared the results towards.
Yes,
this some fixed values only you have taken, isn't it? When you are increasing the data, you are getting some equal values only now. What you have adapted already existing. Can you see that?
Yes, madam.
1, 5.
Exactly, madam. Yes.
You are not having a what is it?
At the end, after
difference only you are getting, isn't it?
Yes, madam. It is e power to some numbers. So after decimal place, after many zeros, they are changing. And that is why we compare our method with this NHPM, that is natural homotopy permutation method, which is very effective method to solve a fractional order partial differential equation.
So this X value might be, all the X values it will be tallied. Have you checked?
Yes, madam. All the values checked for Gardner. This is for second, as well as for Fisher equation, and it is available in our submitted paper.
Okay. It's a nice presentation. All the best.
Thank you very much, madam. Thank you.
Thank you, ma'am. Thank you, sir. We'll move on to the next presentation. Geeta Lakshmi, ma'am.
Okay.
Are you ready?
Yes, ma'am. Good afternoon, ma'am. Ready, ma'am.
Yeah. Please share your screen, ma'am.
Okay.
Ma'am, what happened?
Geeta Lakshmi, ma'am. Sir, she is not there in meet, sir. We'll move on to the next candidate, Ravindra Nahi, sir. It's the last participants.
Hello, good afternoon.
Good afternoon, sir. Good afternoon, sir. Please share your screen, sir.
Okay, ma'am.
Okay. Sir, we stick to timing for 10 minutes.
Okay, sure, ma'am, sure.
Yeah.
So good afternoon, everyone. This is Ravin Negi, a senior research fellow in the Department of Mathematics, HNVGUC Nagar Karwal. So the topic of my manuscript is the unsteady peristaltic flow of a dusty nanofluid in a curved channel with the heat and mass transfer under the magnetic and the thermal radiation effect. So this is the outline of my presentation. So basically the peristatic motion, which refers to the wave-like contraction across the walls of a channel, or you can say the tube, which enable the movement of fluids. And this phenomena has both a natural and industrial context. Also, in the biological system, it plays a main role in processes like moving food through the digestive tract and the facilities fluid circulation in tiny blood vessels. So in this study, we have examined the inconsistent two-dimensional peristatic motion of a dust-enriched nanofluid inside a circular flow path. And our primary goal is to analyze the flow and heat transfer characteristics of the nanofluid under the influence of the peristatic waves in the curve geometry. So, in the previous study, the motion in curved geometry have been widely studied, but in our study, we have studied the uniquely explored the dust enriched nanofluid peristatic in a curved channel, which analyze the different physical parameters like velocity, pressure, temperature, and heat transfer. So this is the figure A is the physical model of our problem, where we have to consider the unstudied two-dimensional peristatic movement of a dust and this nanofluid within a channel of curve A. And the modeling setup and the associated coordinate system is illustrated in the figure A. So the r-axis is oriented perpendicular to the channel surfaces, while the x-axis run parallel to the channel walls. And we have taken here the width of channel is 2d1, which is embedded within a circular structure of radius r star, and the center denoted as a O. So under the all consideration, the equations, the co-equation of the problem are systematically derived to the capture the dynamics of flow, heat transfer, and other relevant physical phenomena within the system. And these equations are grounded in the fundamental principle of mass conservation, momentum balance, and energy conservation, ensuring a comprehensive representation of the system behavior state. So in the fluid phase, the equation 1 is representing our equation of continuity. Equation 2 and equation 3 representing our equation of momentum in x and r direction respectively. And the equation 4 representing our equation of energy in fluid phase. And in the dust phase, the equation 5 and equation 6 representing our equation of momentum in x and r direction respectively. And the equation 7 is representing our equation of energy in dust phase. And the equation 8 is all the required initial and boundary conditions of the problem. So next is the methodology of the problem. So to solve our mathematical problem, which is a couple of partial differential equations along with the initial and boundary condition, we have used here the finite difference method to solve it numerically. So to solve our system of equation, we just discretize our space in the finite space, as you can see in the figure B. So we have used here the value of x maximum is 125, r maximum equals to 50 with respect to x and r axis. And we have taken nx equals to 150, which is a grid space, and ni equals to 150. And a smaller time step delta t equals to 0.005 have been taken. Also, the constant in dimension are regarded as delta x equals to 0.8 and delta r equals to 0.2. So next, what we have done in this methodology, we just convert our all system of partial differential equation into the finest difference equations, and we solve all these equations in a MATLAB software and get the required results. So equation 9, equation 10, equation 11, 12, and 13 all are the finite difference equations of our mathematical formulations, which I have earlier discussed. So now we have the results. The first result, as you can see the figure 1, which is the velocity profile. So we can see that our velocity u, which is in a parabolic profile across the channel with r, and for different values of x and t. So here we can see the velocity reaches at the highest near the channel when the R equals to 0, and this is due to the minimal wall interference, and it decreases when R equals to 1, and this is due to the no slip boundary conditions. So as we can see that as increases, the velocity is moderated at x equals to 0.2 and t equals to 0.1. This is our second result, which is a graph for the pressure distribution. So the pressure P decreases steadily along the channel length X across all time step T, and this pressure gradient is the driving force behind the fluid motion, which enabling the sustained static pumping. And the figure 2 reveals that the pressure gradient diminishes as T increases, indicating the development of the steady state flow pattern over time. And this behavior is characteristic of the pulsating motion in curved channels, where the curvature significantly impact flow resistance. This is our third result, which is of the temperature. So the flow temperature T exhibits a slight parabolic distribution across the channel length, and it reaches to the maximum at the channel center line equals to 0, and decreasing near the walls, which is at R equals to 1. And over the time, as the time goes on, the temperature gradient diminishes, reflecting heat diffusion and the progression towards the thermal equilibrium within the channel. And this behavior aligns with expectations as the curve geometry and nanofluid properties contribute to the enhanced heat transfer. This is our next result, which is for the stream position across the channel R at various time steps T, reveal the follow pattern saved by the oscillatory motion of the channel walls. And we can see at T equals to 0.1, the streamlines are densely packed, indicating the higher flow velocity. And next is our wall shear stress straw, which decreases along the channel length X and over the time T. And the higher stress value near the inlet point X equals to 0, which indicate that the stronger fluid wall interaction due to oscillating walls, while lower values downstream suggest a relaxation of these forces. So this reduction is essential for understanding particle-fluid interaction in dusty flow. Next result is for the Nusselt number profile, and the Nusselt number expressing the convective near conduction rate decreasing along the channel length X over the time T. So this trend reflects the diminishing temperature gradient near the walls as the fluid approaches thermal equilibrium, and the higher value of Nusselt number values near the inlet indicate enhanced heat transfer driven by the curve geometry and the nanofluid properties. So these are the conclusion of the manuscript, which I have already discussed in the resultant section. So for the future work, the future research can explore the influence of variable wall properties such as elasticity and permeability on pulsating motion in curved channel, and investigating the impact of magnetic fields on dust and nanofluid flow could provide valuable insight for biomedical and industrial application. And also we can extend this research to three-dimensional flow models for a model comprehensive analysis. Also we can incorporate non-Newtonian fluid behavior, time-dependent boundary condition, and slip effects at the wall could refine the understanding of heat transfer dynamics. So, and this is the latest 5 references from the reference list of my original manuscript. So, thank you.
Ma'am, please ask the question.
Yes, sir. Good afternoon, Ravi sir.
Good afternoon, ma'am.
Yeah, actually, you have given various type of distribution, isn't it? Velocity as well as pressure, everything. This is only for
Yes,
2 dimension you have taken, isn't it?
yes, ma'am.
Yeah. So, which when I have seen for the 3 dimension, is there anything I've tried, or because here it is all the 4 variations you have given. Have you tried anything in the 3 dimension?
No, ma'am. In this manuscript, I have not tried for the 3 dimension, but we can explain this study for 3 dimension. demonstrates
Any
as well.
peculiar 3 dimension it is giving the best result? Can you any give application? No,
Application?
any peculiar, like some sort of 3 dimensional view, any applications, 3D, this will be best result. You have given a
Yes,
generalized
ma'am.
one for 3D, isn't it?
Yes, ma'am. It has an
Any
application in
3D
the
specifically?
specifically 3D, ma'am.
Is it
Yes, ma'am,
audible?
you are audible. In 3D, ma'am?
Ravi sir?
Yes, ma'am.
Might be my
Hello.
network is also slow.
Hello.
Yes, sir. Anyway, it's a very nice presentation. I have
Thank you,
seen
ma'am.
like this fluid.
Yes, ma'am.
So you please go
Ma'am, your voice is cutting off. Sorry. Hello.
Hello.
Hello. Hello, ma'am.
Hello.
Hello.
Hello. Rahul, no issue. Just I will take care of that. Okay. Am I audible? Am I audible?
Yes,
Yes,
sir,
sir.
you
You are
are
audible,
audible.
sir.
Okay. In the result part, no, you shown. I think you presented the six result. No, six. Am I right?
So voice is cutting off.
No, you have presented six result. Am I right?
Yes, yes, sir.
Okay. In the result and the discussion part, no. Okay, result and the discussion part. In the
Yes,
first
sir.
slide, no, the figure one.
A second. Let me reshare my
Yeah,
slide, sir.
no issue. Just I am telling. Okay.
Yes, yes, sir.
In the figure one, no, velocity profile, no.
Yes, sir. Yes, sir.
Yeah, you got some what is that increasing then decreasing pattern? No, you got some increasing and decreasing pattern.
Yes, sir. I got the
Uh,
increasing and decreasing pattern on my results. Yes, sir.
yeah. What is your interpretation of that pattern?
Actually, sir, our main aim is to say that our fluid flow.
Yeah,
Just
you
to
used
invest,
the blood pressure, no?
yes, sir. Just to investigate the fluid flow while affecting the different physical parameter on it with different values. So how they are affecting our fluid flow. So that we can encapsulate with the fluid flow with that physical parameter fixed values.
Okay.
Yes.
Could you please tell me the what is the real the fact situation in the people?
Sorry, sir.
In a days, so many people are affecting their blood pressure. No.
Yes, sir.
Yeah. So you have to give some result for the layman people. Okay.
Yes, sir.
So
But
based
in
on that figure, based on that
yes,
figure. So what is
yes,
your interpretation for your layman people?
actually, in through this manuscript, we just physically physical parameters which are affecting the flow. We have not in touch of that biomedical applications, but mathematically we are just trying to interpret how the flow is affecting with different physical parameters, sir.
Okay.
Yes, sir.
Okay. Well, the topic is very excellent, and your explanations is very excellent.
Thank you so much.
Please go ahead for the future study. So thank you
Thank you
very
so
much.
much. Thank you so much. Thank you. So much.
Hello.
Yes, ma'am.
Hello, ma'am. Hello, sir. Can I present my presentation? I'll be few slides only, ma'am.
Please ask the admin, ma'am.
Gita Lakshmi, ma'am.
Due to network problems, yes, ma'am. Shall I
Yeah.
present, ma'am? Just 2 minutes, 3 minutes.
Sir, they have a network issue on the track. Sir,
that time, ma'am.
shall we allow them to present, sir?
Okay, ma'am, you decide, ma'am.
Okay, sir. Okay, sir.
Just a few minutes.
Ma'am, we stick to 5 minutes, ma'am. Please share your screen and present your.
Okay, ma'am.
Okay, ma'am. Please share it, ma'am.
Is the screen visible, ma'am? Ma'am, is the screen visible, ma'am?
No, your screen is not visible.
Not visible, ma'am.
Rahul, sir, please.
I have shared the screen, ma'am. Is it not visible?
No, it is not at all visible, ma'am.
1 minute.
கடவுளே யூ டிசைன் மேம்னு சொல்லிட்டு ஒரு பாட்டு மியூட் பண்ணிட்டு போயிட்டாரு. நான் சொல்றேன் இப்ப கீதானா அடுத்து சும்மா எல்லாம் வருவான்.
Ma'am, any problem, ma'am?
No,
Geeta,
sir.
Geeta Lakshmi, ma'am, any problem?
No, ma'am.
We will end the session soon. Ma'am, okay, ma'am, we will end the session, ma'am.
Yeah,
It's
okay,
already
ma'am.
yes, yes, it already become time elapsed in Zoom meet. Yeah, that's why we have called your name for 2 times. And
Yes,
also,
ma'am,
yeah, before the session itself, we have, yeah, sorry, ma'am, sorry for your. Excuse, ma'am. Ma'am, actually, 1:30 session will be going to end, ma'am. Already we fixed. So sorry, Geeta, ma'am. After that, some more participants is also asking the time for presenting a paper. So please excuse us, ma'am. Geeta, ma'am.
Okay.
Geeta, ma'am. Till now, your screen is not visible, ma'am. That's why. We have only 8 minutes. We are going to end the session.
Okay, ma'am.
Okay, ma'am. Okay, sir. Okay, ma'am. It's time to end our
Please
session.
allow to present.
It's time to propose our vote of thanks for this session. Good afternoon to all. I deem it a great honor and privilege to propose the vote of thanks on this 2 days international conference on advances in applied sciences, technology, and mathematics. Let me first of all start by giving a glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special judges, Dr. N. Sundaram, Associate Professor and Head of the Department, Nandanam Government Arts College, and Dr. N. Sujata, Assistant Professor, Senior Grade in SRM Institute of Science and Technology, Ramapuram. We are grateful to our management for the encouragement, guidance as always encouraged us. I thank our principal and VP for their unstinted support for this conference. My heartfelt thanks to the head of the department and the faculties. Thank you all. Thank you, sir. Thank you, ma'am.
Thank you very much, ma'am, for the opportunity given by Sri Krishnaswamy College of Arts and Science College and management and staff members. Thank you very much, ma'am.
Thank you, sir.
Thank you, ma'am, for giving this opportunity.
Thank you, ma'am. Thank you so much, ma'am. Thank you for your valuable time. And thank you, sir, for your valuable time.
Because this is
Okay, sir. Thank you.
Okay, sir. And thank you for all the participants who joined for the today's session. We'll end the session now. And
Anyway,
this
it's a
session
very
will be
nice way of
streamed in the YouTube. Yes, ma'am. Yes, ma'am. Is the session will be streamed in YouTube. We'll inform you that in the group, WhatsApp group. Thank you. Thank you all.